research platforms, and those platforms should be used for a sustainable society. And we really focus on global research in general. So this is just to give you an idea of our makeup and time where our offices are located. We have 4 nodes that focus on terrestrial sciences. We've got one, the global node, which is based in Palabora. We've got the grasslands node, which is in Tamarisek. We've got the arid lands node, which is in Kimberley, and we've got the famous node, which is based in Cape Town. And then we have 2 marine nodes, and both of them are based all over the coast. So the one is the Egagasini node that focuses on offshore oceanography, and that is based in Cape Town. And we've got Elwan the node, which is in Durban. And we also host 3 research infrastructures. So you must know about the South African Research Infrastructure Roadmap, SRB, which is a DSI program to assist with basically establishing large research infrastructure. So Zion hosts three of those, and we have a national office which is in Pretoria. So just coming to the topic of this session around extreme weather, I thought I would remind you of this report which was mentioned yesterday in the opening session, the global risk report. And what I'm showing you are the top risks that were identified in the 2021 report, in the 2022 report, and in the latest 2023 report, which was published a few weeks ago. And you can see extreme weather keeps coming up. So when you look at the 2021 report, you see it's appearing as the one with the highest likelihood. And then when you look at impact, you can see it's relatively higher up when it comes to impact. And when you look at the 2022 report, you see extreme weather appearing there as second, and the 2023 report considers both, the risks in the next 2 years and risks in the next 10 years. And you see extreme weather appears as second in the next 2 years, and as third in the next 10 years. So that in itself says that we really need to be talking about this index. We downloaded some of the MDAT data. I know there's a whole conversation around whether this data set represents all the data, all the disasters or not, because they are very strict with the criteria of what makes it into the database. But just saying of what made it into the database in South Africa, what are we seeing? So what you see here of the histogram, so this top part shows you what has come up in when you look at the whole African continent, and the one below shows you what we see in South Africa. And what's coming up with that floods seem to be causing most of those disasters that made it into this database. And looking at South Africa in particular, you have storms that are coming up as second. That line graph there shows what has changed over time. And when you look at the whole African continent, you can see that there are times when there were a lot more events, and then in South Africa itself, the events that have been recorded, they've not really increased all that much. But then last year we had many events. I think there were already 4 events that had been identified. We asked Halal Exam, one of the scientists at Zion, just to identify which municipalities reported more of the events, and you can see KZN really is coming up with most events having been recorded. And then you can just see the distribution, depending on the type of event that we are looking at. Now, the issue of early warnings, I mean, this has been mentioned since this morning. We've had a whole lot of talk that has just focused on early warnings. We've got State of the Climate in Africa reports that get published. So far, there have been only 3 reports, but in each of these reports, I mean, they list the extreme events across the African continent and their impacts. And the recommendation is also that we need to improve our early warning systems. And if you check our very own national development plan, you check chapter 5 of it, it speaks also to issues around early warning systems. And in particular, it also mentions, climate modeling capacity, so that we can be better prepared for these events. Last year on World Meteorological Day, the head of the UN made an announcement that they want to see in the next 5 years everybody on Earth having access to early warning systems, and obviously that needs to be resourced. And given COP in Egypt last year, there was then an announcement on election plan unveiled by the WMO, indicating what financial resources they need for this in-voting system to be realized. Now, I think in terms of the value chain, different people can represent this in different ways, but if we are to ask what are the components that we need, we know we need an observation, we need observation networks. For anyone to be established, we need models. So the numerical models allow us to have a longer lead time. If you take observations and just extrapolate from the weather point of view, now casting you can do up to about 2 hours. Beyond that 2 hours, you need to use numerical weather prediction models. And I mean, to give seasonal forecasting as well as climate change projections, we rely on these climate models. And obviously, you have post-processing where now we can bring in observations again to bias correct the result. And then you have scientists that can deal with all that results. You can do develop some products for climate sensitive sectors. And then you have some dissemination, which is also an area that I think as the continent we are struggling with. So in my talk, I'm not going to speak to the areas from post-processing. I'm going to focus on the observation side as well as on the models, sticking to what we are doing at SCION. So when we talk observations, there are people that say I've got access to satellite information, and therefore I don't need in situ observations. And this is just to show you that really does not work. So what I'm showing you here is 24-hour rainfall. So this is for a study we conducted over Botswana, and that one is for a study we conducted over Zambia. So for this one, these 4 figures you are seeing here are all on the same day. So the question that we are asking here is that in that 24-hour period, how much rainfall was received? This is from the ground observations from the Botswana Met. That is a project I met from NASA. This is a project, it's called TAMSAT from University of Reading. And this is from the ERA5 analysis. And you can tell that these are very different from each other. Now the question is, if I'm to run my models and ask, is my model performing well or not? When the observations are very different from each other themselves, am I going to make any progress with the models? And that just to show that it's not something we found only over Botswana. We found it, we're working with 5 different SADC countries, and it's something that we found. So this was an example for Zambia, one case study, and all of them, you can see, they look very different. And these are all supposed to be observations. So what that does is then that when we run sensitivity studies, we have issues. We did some analysis where we were looking at sensitivity of heavy rainfall events to a different parameterization schemes. So we looked at sensitivity to cloud microfluidic schemes. We used mostly single moment schemes, and what we found was that the different simulations with different cloud microfluidic schemes looked more similar to each other than to the observations, while the observations themselves looked very different from each other. So this is something we did for Botswana. Then for Zambia, we looked at different planetary boundary layer schemes, and we looked at different types, local, non-local, TKE-based. Then again, we found that the simulations look more similar to one another. So this is the example for Zambia, and you can see that if I say now these 2 are my observations, and I'm trying to check which scheme performs better. You can see I can't say anything with that. The one thing we found was that the convection scheme, selecting different convection schemes resulted in bigger differences in the simulations than when you consider some microfluidic schemes or the planetary boundary layer schemes. But having said this, we know that there are shortcomings in the models. So here I'm just showing an example of simulations we made with the system. So the system is the model that Francois presented on this morning. So this was that 21-22 April 2019 band. And if you are to compare, so these are different configurations of system, and these are the observations. And you can see with the observations you're getting higher rainfall here, while in the models the higher rainfall is here. So we do know that there are shortcomings in the models. There are studies that have been conducted looking at weather radar at the South African Weather Service, comparing how models perform when they simulate thunderstorms, and the study found that the models are able to capture the extent of the thunderstorms, but not the intensity that is associated with this. And that in itself then causes us issues when you're supposed to issue any warnings. How do you issue warnings when the model is underestimating events? So the event. So it's also something we found here. We're looking at how many 6 different high impact events, and where we had the most rainfall, we found that the model, so the blue one is the observation, while the different color, the other different colors are different configurations of the model. So when you have an event that produces a lot of rainfall, the models just don't capture that, they underestimate that rainfall. Now the question is, do we just give up and say, no, we are Africa, we don't really have observations, or do we try to contribute to these models? So I'll just talk, I won't get into a lot of details about what we do, but that's just to show you that within SCION, we have got a number of landscapes that we are studying. And the idea with our landscapes is that, we focus on a small area and we put up a number of observations, and out of that, we get to understand what is happening with weather and with climate, like in the long term, like with weather, get to understand the events themselves as they are happening, and then get to understand the change that is happening, either it's remaining induced or if it's that natural variability. And you can see those different colors represent different biomes. So our nodes or our landscapes have been located such that we try and cover as many biomes as possible, as well as a different climatology. I've already mentioned this one, the South African Research Infrastructure Movement, that we host 3 of these. So the first one is called the Expanded Freshwater Terrestrial Environmental Observation Network. So SCION has been hosting this since 2017. SARIR itself as a whole was launched in 2016, and there are 18% infrastructure as a whole in South Africa that are being implemented. So it's being run by the Department of Science and Innovation. So with FTION, we have identified 6 landscapes that you see being located there, and the expectation with those landscapes is that, again, that we need to really understand what's going on there, how as humans you're also interacting with the environment there. We are now in the process of getting automatic weather stations, and we expect that in each of those landscapes we'll have at least 6 AWSs. And then I think in terms of measurements, like the normal meteorological measurements, we'd like to make those. Atmospheric chemistry, we also want to study what's happening with the hydrology, looking at both the quantity as well as quality of water. Then the second one we have also, we've been hosting it since 2017. In fact, of the 3 is the one that is the most mature. It's called the Shallow Marine and Coastal Research Infrastructure. And in terms of, I'll say, head office for this is in Gabeka. And with this particular research infrastructure, we want to be able to take observations of, the coastal areas. We've got, for example, a temperature observation network that we've got across the coastal line of South Africa, and we are engaging with Mozambique and Namibia so that we can have that observation network extending north of us. We also have a hyperbaric chamber as part of this, because we have divers who need to go into the water and take observations, take samples that we've got labs to be able to to analyze. Then we've got the South African Polar Research Infrastructure, SAPRI. We've been hosting SAPRI now for about a year and a half. And with SAPRI, we want to be able to take observations, basically going deep into the waters, looking at the Atlantic and the Indian Ocean and the Southern Ocean, going all the way to Antarctica. And in terms of the observations, we want to do long-term observations on land, we want to do long-term observations in the ocean. And we are working with the University of Cape Town to establish a polar lab that can be used to replicate the conditions in Antarctica. Then in terms of modeling, we are very much interested in contributing towards models in general and model development. And so adding that was actually very deliberate, that figure there, because it shows you that when you think of the earth system, there are different components you need to think of. I myself an atmospheric specialist, but we need to work with people that understand the land surface, and we also need to work with oceanographers. We know state of the art is not forecasting requires that you run a couple ocean and atmosphere model. Then so in terms of the model development, our decision within SCION has been is that we will continue with the model development activities that we know are most active in South Africa, and those are around CCAM. So within SCION itself, we are also going to continue working with CCAM. We also have capacity around ocean modeling. We are running a program called Shumishana, a Sustainable Ocean Modeling Initiative. And through this program, we are also working with BSI and DFFE around the establishment of an ocean and coast information management system. So we run these ocean models to be able to produce some forecasts, and SCION then develops a platform that's able to share that information. We've got an open we've got a platform that's available for us to share our data. So our data for this within SCION is that it's open. So all the data that we are observing, all the stations that I'm saying we are busy going around, that data is available for scientists to use. And if you want to access our data, you can go onto our catalog and just search for the data that you have. We don't have all our data is yet there. So if you find that, we've got a certain data set and you don't find it there, you can just send us an email and we'll be able to send it to you while we work on making sure that it's available to be downloaded. We have got a very strong science engagement team. They are working with school learners, they're working with the school teachers, they are working with the graduates. We've got a graduate student network. And some of our programs, we are also running some training workshops. Last year we ran one on the power application in PPIS. We also ran one on ocean modeling, co-hosted with the CHPC. The one on NWP is co-hosted also with the South African Weather Service. So I think this brings me to my last slide, which I guess basically says that for us to be able to deal with these things, we are dealing with multidisciplinary research. If people have the models alone, we need software developers to assist you so that you can get your model to run really quick on the high performance computer. And with the modeling, so I think I'm answering questions that Neville asked a little bit, that in that I think the best approach is to use a model that is seamless, and then in that way you don't have to deal with different codes, like for numerical weather prediction, a different codes for seasonal forecasting, and then a different code for information projections. Then with our model development, as I've mentioned, we are going to be throwing our weight behind CCAM as well as the systems that are associated with CCAM. So for the land surface modeling, that will be cable that we will be using. And then with the ocean modeling, the capacity that exists now within SCION focuses on ROMs. So I know Francois is developing another model. So I think that is just a conversation that we'll need to have to say when it comes to the development of these models, which ocean model are we going to be focusing on. So I think the last announcement is just that we will have the South African Eastern Banda Future transition on Thursday, so you'll hear a little bit more about what we are doing to try and assist the country with the.
Thank you very much. I'm noticing in the program, in fact, that you are scheduled, you were given a slot of 40 minutes, but the program is wrong. And it said 20. So we're going to use up 20 minutes, not necessarily with all of your time, because I know you're going to go to a meeting and then you'll come back. So we have a little bit of time for some questions for Mary Jane. And then we can use the time to do some other things to catch up to 1440. So are there any questions for Mary Jane in particular? What occurred to me was this idea of integrating time frames, and I actually got it also this morning with Francois' talk about the prediction of long-term conditions for extreme events. So that's a kind of a climate change kind of question. Then we heard a bit this morning about seasonal scale forecasting, and then we've got short range. And I guess what the weather service, the weather forecast is called long range, meaning more than 10 days, right? and how we go about kind of integrating those different timescales or differentiating between them, and if that's necessary to do, and how important it is, because I guess in early warning, there's the early warning at those different timescales. We have a climate change early warning layering out in various places. We do have seasonal forecasts, which are not weather forecasts, those are climate forecasts, which say the likelihood of a particular season with a range of kinds of events are possible. And then we have the short range weather forecasts and this intermediate period, which is so troubling, which is to say next week, 2 weeks, 3 weeks, a month, etc. So maybe you can give us some point of view on that.
Okay. Yeah, I think that is a relevant question, and I think that the global community has actually been trying to develop so-called, but I would give the example of the UK Met Office. They developed a unified model, and the idea was that it's a unified model that is able to do all time scales. But in practice, it's difficult because you end up with people specializing in different areas. So you've got someone working on numerical weather prediction, just focusing on that, and one doing signal forecasting, actually just doing the signal forecasting, and those that are working on climate change predictions doing that. But I think in South Africa, we don't really have a choice because of, in terms of the models that we're running, we have so many models that we're running. We're running Cosmo, we're running WARF, the ocean models, there's NEMO that's running, there's ROMS that is running. So you end up with just one person focusing on that specific model. So that in itself says we are not going to get to a point where we have a really thorough understanding of these models and really being able to pick out where they are not performing well, or what are the areas that we need to improve. So I think that in itself says as a community, we need to kind of work, not exactly on the same model, but a number of people need to be working on one particular model so that we can be confident that we understand that particular model. But I mean, in terms of the expertise themselves, some focus, like I said, on the weather side, some will focus on the signal side, others will focus on the climate change predictions, but ultimately those are output from the model. And if you look at the basics of these models, the atmospheric side, you want conservation of momentum, conservation of energy, and conservation of land. And it's similar for different time scales. And you look at the ocean as well, they are sort of similar, except instead of conservation of mass, we have the salinity.
Thank you. There are some questions at the back, but I want to first comment on what you said before I give the floor over. So I wish I could show you the graph I have in my head. I'm sure many of you have seen it's a NOAA graph showing time scale on the one, and I forget what's on the x-axis, but the time scales from like minutes to hours, then days to weeks, weeks to months, months to years, and then they categorize those in sort of tactical, strategic, and I forget what the third category is. And in a sense, that's a sort of a unified approach in terms of being able to forecast. And I guess the idea of a unified model, which does it all for us, is a dream, but I take your point about it being fairly fragmented still by discipline. And then this morning's conversation, which also spoke about the breadth of the application. So not just the model predictions, but also the applications have to somehow be integrated into a bigger kind of a model. It may not be a numerical one, but certainly that has to happen. So that's what I wanted to respond. Now I'm going to give the floor. Sally, thanks.
Hi. Yeah, thanks for a great talk. I suppose just to follow up on this discussion and your points around model development. I think I hear you saying you think model development is very important and we should be mobilizing around that and coalescing groups that have this. And I just would really like to believe it. So I think in my experience, it's the type of people who want to do model development who haven't been part of use models have had to. And we in South Africa, the levels that we can add to this global enterprise is often the model development. We understand our web systems and our systems. And yet the students we train are often don't want to go in that direction. And the capacity is spread across the institution. And so we never I mean, I don't know about the plants, but the vegetation landscapes not recent. We've never made any specific contributions, even though that's where I think we have the most capacity to begin. So I would like to maybe initiate a discussion on how to progress and coordinate the ongoing business.
Jen,
That's on. Thank you, Jane. My question is probably quite similar to Sunny's, which relates to specifically the EMBAC staff days that we spoke at the beginning. And our selection of indices when we're speaking about three different things. And of course, there's been a huge effort with them to go to the ETCPI and the ETACI schemes. We've got all of the discussion around SPI with APEI. But I don't think that there is enough work on really coming to a common understanding about which indices are most applicable and most valid in our local context. When we drill down to the assumptions of any of the indices, when we consider the fact that many of these indices are better to the northern hemisphere and being applied to quite different climatic conditions in the southern hemisphere. And so, as Sally's arguing, I think we also need to be putting quite a lot of focus instead of just applying it, but to really critically engaging with what indices we have at our fingertips and how we're going to calibrate it. So, for example, with the ETCPI, on my experience on our work, that there are a number of places where we put in our input pressures. And how are we determining those, and to what extent is that a conversation within the Southern African climate community or global change community, or to what extent is it the individual researchers who are making those decisions with valid reason and putting that into their intersection, and resulting in work that is not comparable between two different studies or two different regions, because your threshold for heat waves is 3 days here and 5 days there, or you're looking at the 95% versus 90% of. And so on and so forth. So I think it's mostly a point, but my question is in terms of your new role at Scion, what extent can organizations like Scion, like the South African Weather Service, like the CSIR, start to drive engagements towards common understanding of our industry with a common approach so that we're providing comparable and meaningful outcomes?
Those are two very big questions, but I think what this one is really more of a comment in a way to agree that we need to develop our own models, and yes, that's exactly what I'm saying, that we should be developing our own models. If you look, for example, at WRF, the Weather Research and Forecasting Model, which is used widely, they've got what we call suites. That they are parameterization suite, and that is because we have not found a model, we have not been able to develop models that work well everywhere. So as a result, they would identify one and say this seems to be working better in the mid latitudes, while this particular suite seems to work better in the tropics. And the point is that we have really not been part of that conversation. So around the lens phase, Greco was mentioning that what they were looking at in people, what this vegetation type that we're supposed to have in the model was completely different to the one that you are observing. So that in itself says we cannot sit and just wait, for somebody to come up with solutions for us. If I find now that the model is underestimating events, if we don't contribute to the model development discussion, that means I have to wait for somebody in the US or somebody in Europe to come and fix that for me. And they are busy with they are focusing on their areas, and they're also trying to get the models to work better for their areas. I think on the indices side, I want to agree. It's not something I've thought about regarding how we can do it, but it's definitely a discussion that we can have within Scion. And I guess also engage with Access and Source, see how we can assist with that. But all these actually just speak to just the whole environment where as South Africa, I think we have become comfortable with using things that we are getting. The same thing is actually happening with the centers, the AWSs that we are buying. I mean, sometimes we get a quote, and then by the time you are able to buy, the dollar-rand exchange is very different. The rand has gotten weaker, and that in itself says that what you are buying has become more expensive, not because you are getting more, but simply because the rand has gotten weaker. And the question is, shouldn't we have an environment in South Africa that allows us to, to have our sensors that you know, where you get more for your money and you don't lose value, or you don't lose on the quantity that you can get just simply because your currency has lost its value. So it's also the same with the satellite information. I showed you here the rainfall estimations from satellite information. Who makes those estimations? Clearly they are wrong, because one says there was rainfall, the other one says there was no rainfall. So there is also something to be done with that area as well, to say we need to be contributing to be coming up with these you know, quantitative precipitation estimates and asking questions around the parameters that are being used applicable for South Africa.
Thank you. I'm gonna suggest something. First of all, in terms of sensors, yesterday we heard about the PCO2 sensor from SOCO, right? And they're doing very well. They're selling, there's a lot of interest in it internationally. There's an example. And indeed, with our weather stations, I don't know how many of our sensors are imported or locally produced, but that's really, that's one point I want to make. The other point I want to make is a controversial one. And we've just finished a report for SAWS that is Alina here, and not for DFFE. Alina and Charlotte know about it. It's a report on the National Framework for Climate Services. You know about it. And in that report, I tested, well, I don't quite know that the report has the statement as I'm going to say it, probably far more subtle than I'm going to say it. And that is that when looking at international examples of national frameworks for climate services, we looked at India, Japan, and Brazil, and Australia. All of them have got climate science strategies, and they've got programs, national programs around climate science. Now, this is not divorced from impact and downstream utilization applications, but there is a distinct focus on the climate science, a strategic approach. So, and all of those countries, by coincidence, have their own models, more than one model, okay, which they use as we are developing here. And so my statement is that what we are lacking here in South Africa is a strategic approach to the climate science. Now, I know we're drifting off slightly with extreme events, but obviously one of the applications is extreme events. But would you agree with my statement that a strategic plan on climate science is something we need to think about as a collective in this country? So yes.
Yes, I agree with that, because I would say in terms of capacity in South Africa, you look at work that has taken place in the different universities, it's CSIR, it's all, there's a whole lot that is going on. But I think in terms of talking to each other, we have not really done very well with that. I think there was a time when we were collaborating a little bit better than now. So I think having such a strategy will then help us in terms of, you know, how best to talk to one another. And it will also help us in terms of resourcing. I mentioned that the NDP, sort of of the NDP, they talk about, in terms of the recommendations, they say we need to get to a point where we are better prepared, and that is through the use of climate change projections. And the other recommendation they made was actually that NRS needs to establish a center that would fund climate modeling capacity. So that is one thing that I had not noticed before. So it's something that you can see that around climate science, there's a lot that needs to happen. And with this lot that's happening, everybody that does something comes up with a recommendation that something else needs to happen. And that in itself points to a lack of that strategy, because that will affect that.
Good. I'd love to elaborate on my thinking, but I don't think this is the right place to do it. But we're going to take it. Mary Jane said it, you all heard it, but but either way, I do think that is something we need to do, which is a subset of global change, obviously. So we don't want to divorce it from its applications, but certainly what modeling, you know, what scales, what indices, what systems, those kinds of things, and who does what divisions of labor, funding, all those things. So without editorializing anymore. Any more points? We have one here. One
Thank you so much for your lovely presentation. I really enjoyed it. I think while people were asking questions, I was touched by your first bullet point in your conclusion. And I am aware that there is an establishment that I have in UCT whereby, people can learn about the different temperatures that are currently occurring in Antarctica. And I believe that the change in temperature is also caused by climate change. In that, I'm also looking at maybe having partnerships with individuals that are not studying such a subject. They say, like I know in Exodus that they study science systems and it's a collective of different students. So I'm willing to open your doors to individuals who are in such programs whereby they can go to the hub and see or feel or understand the different types of temperatures that are happening in Antarctica, and then we can also relate them to the earth science systems that we are currently living in Texas.
Okay, it's great that you asked that question, because I think if there's one message that I want to portray is that what we have within Zion, we're a national facility, or not yet said as a national facility, hoping to be. But the point is, whatever infrastructure we're establishing is available, and not just for South Africans, for scientists globally to come and use. So the polar lab that's being set up at UCT is going to be available to all scientists. So it's not being established for Zion only. So it's the same as I mentioned, even with the data sets that we are collecting. So it's for the betterment of South Africa. Researchers can have access to the facilities that we have. So be it the polar lab, be it the landscapes that we've got available, you can come set up your experiments there.
Right, I think time is up. So Mayor Jane, thank you very much. And I know you need to go to a meeting and we'll see you a bit later on. Thank you very much. Okay, so we're going to go back to the program. But before we do that, I just want to do this. Yeah. Okay. Nobody's allowed to leave. No one can leave. We're going to do that. Okay, so we've got a couple of talks now. Team after Nicole. But first up is Ruthie, my boy, who's going to talk now. And I just want to point out for those of you that work in the morning session that there are these questions which we want you to answer. And we're going to just distribute the questionnaire. You can write the answers on the back. Don't worry about the colors. Okay, so Ruthie, here you are. You close that and open yours, which is this one. And the floor is yours. Thank you.
Hi everyone. If you see me being awkward, it's because I've never spoken with the mic in my name. My name is Ruthie, and this is what I've been doing as Zion Global Node for the past couple of months. So I'll be speaking about our findings on the historical rainfall data in our region. So as a water service country, we tend to have a panic when it comes to the availability, the supply of usable drinking water. And with global climate change talk, I mean, it's high time that the management and the management system as a whole for the natural resources to start looking at adaptations of the plans that they have already, because clearly the plans are not working. Our rural areas strictly in our region, strictly rely on rainfall when it comes to domestic use with domestic water use. And so if we study looking at the measured rainfall data, we are able to detect, the changes thereafter, and we will be able to mitigate and plan better for local regions instead of just looking at it nationally. The sites that we had focused on are namely Heidelberg and Maritzburg. Those are the two, I mentioned it this way because they are high rainfall areas. And Phalaborwa and Hoedspruit are fairly dry areas. So this is a basic feel of what Phalaborwa and Hoedspruit is and Maritzburg and Heidelberg is. So, oh yeah, that's totally the person I was looking at. So when we looked at the, thank you. When we looked at the long-term rainfall data, we realized there's a lot of missing gaps within the data. And we decided to use the neighboring stations to fill in those gaps so that we could analyze it better. Look at the monthlies, look at the annual data, look at the annual trends and changes, look at the seasonal trends and changes, and then look at the rainfall events. So we collected the data from South African Weather Services. There were 17 stations of varying from 30-year data to 30-year daily rainfall data to over 100 year daily rainfall data. And then we used science stations for the more recent years. If we look at this, these graphs, their representation of the deviation from the long-term mean annual rainfall. And Phalaborwa and Hoedspruit, being the drier areas, we would have expected the rainfall to have reacted in the same way where the annual rain would be dipping, but only Phalaborwa was showing such a significant dip, although we suspect that the data was not, had a little, had a few errors within them, considering the gaps there. You can see there's quite a lot of gaps within the data for Phalaborwa. And we also looked at the geometric, this is a mouthful, geometric mean of length of intervals between rainfall events. So with that, we realized the length between the events for Phalaborwa and Hoedspruit reacted similarly, where they did, and Heidelberg and Maritzburg, which are the high rainfall areas, also reacted fairly the same. We also looked at the geometric mean of the event sizes. And Hoedspruit clearly shows a dip when it comes to the event sizes, meaning the rain, the larger rainfall events have fairly disappeared, because clearly the ones that we have been seeing, they are around 10 millimeters. So before I get into this one, we did test for the seasonal rainfalls and their patterns and changes. Unfortunately, it didn't show much of a change enough for us to present. But with these, the frequency of the extreme events, only Maritzburg was the one that kind of showed in the 100 millimeter length, them being more frequent, over 7.5 around the first decade of the 2000s. But the other ones didn't show a clear pattern of extreme events. And so the annual totals decreased with all 4 sites. And I should have mentioned, we had tested for 6 sites. Unfortunately, Hebron and Selipi had, I hope I said it right, Selipi had too many errors within their data for us to actually use it to see a clear pattern. But also we can see that with the event sizes and the event interval, there were some that showed a decrease at p is equals to 0.05. So the challenges that we had, I think I already mentioned this as I was speaking, the gaps within the data, there were large gaps within the data. It was clearly evident with the Phalaborwa data because we couldn't find a supplement for those gaps. So we tried to use the neighboring stations, but unfortunately for that, because of the distance, we're not really sure if those stations were experiencing the same rainfall events at the same time. And with the missing data is discontinuous. Just like your manual gauges, we're not really sure if they've been checked daily or recorded correctly. And so we could see the errors there within our data and our trends, but we'd like to acknowledge that some of our trends could be questionable because of this. In conclusion, the rainfall patterns only slightly changed. There was no significant just unlike places like your KZN with significant rainfall events occurring. And also, if we continue the data within those available historical rainfall data or stations, it would be easier for us to kind of predict, because if we know what happened before, if we see what's currently happening, we'll be able to predict what might happen, or at least have an idea of what we could do to mitigate the changes that are happening globally by looking at it locally in each other region, instead of assuming that everything inside Africa is going to happen similarly. Thank you.
Thanks. Timothy, you've given us a fair amount of time for questions. I just want to see if there are any from the floor. There is one at the back. Is that Alina? And another one over here. Another one over there. Okay, let's see how we go. I also have a comment to make. Which I'm going to make.
Okay.
Hi, thank you for such a lovely presentation, but I think it's more of a comment. And I told you I do have a comment and an issue. So yes, it goes back to what we were discussing about model development. Yes, some of us are on the other end of model development because we are application. So if you really have like the unified or like if their own strategic plans to have like really work on the model development, then it means our research like as South Africans will continue in behind. And also what I want to know is how did you deal with that in in the news and when you. I've seen that in a couple of studies and that they use data in staging. Yeah, I'm not really familiar about it, but I think that it's something that we should try to consider. To promote laws, but that using the example, yeah.
Thank you. As Mary Jane had specified, like this is work for science, so the sharing of data, the collaboration of other sections as well is something that we're working on. And yeah, that commences for but yeah, she addressed that. And I think what we're trying to do is also work with mostly locally with every single node to have a focus study on the changes that are occurring right there and then, so that we could have a generalized idea of what each what's the word? What each individual site with this climate and its innovations and climatic situation and their changes thereafter would look like. And for your question, please.
But how you dealt with missing.
Oh yeah.
data.
So what we did was looking at the source data. So like Palabra data, they have stations that were recording from 1930, and then it stops somewhere around 1950, and then they start a new station right next to it. And then they move on to the next station next to it. So it would have a few gaps, maybe like a couple of months or a couple of years in between. But Cyan also has stations that have been running, but it was for the more recent years. And so we use that data to sort of supplement the missing data from SARS.
Just to comment that, I mean, you can use interpolated data, model sets and other things to kind of estimate what is missing from when the list is created there.
Yeah.
What you've got and what the resolution is you're after. I guess there are methods, but they're always imperfect. And then I wanted to say that, again, in the study I referred to, we got some information on the performance of the observation system, as in the weather station observation system of the ARC. And I know that this is a similar challenge to SARS, is that in fact, in real terms, if that inflation into account, the amount of funding going into the observation system has decreased, and hence performance has decreased. So our observations are under threat, and none of this work can happen without long-term good observation. Never mind expansion. So it's a real challenge. Real challenge. We have time for 2 quick ones, please.
Thank you for the presentation. I also have like a question and a question. A question is, when you were filling in this thing data, or before that, you said, was it a station at the same location or it was at the same location? Okay. And also you spoke about human error in terms of string gauges, not string gauges, rainbow gauges and all those. So the comment was that I feel like you actually do homogeneity tests in your data sometimes in order to have confidence. Because, okay, I'm from ARC, sometimes a station can be close to a particular station, but if you test homogeneity for that data, sometimes we find out that the data is inhomogeneous, meaning that it may have been affected by other things besides climatological factors. So I feel like if you don't have confidence in such kind of data, since it will have biases when you are analyzing it. So I feel like doing homogeneity tests
before making conclusions on data like precipitation data, it's actually a good idea.
Thank you for that. It's actually a discussion that I had with, Tony, using the double mass analysis to check for your, consistency and, homogeneity of the data. And also including, spatial interpolation, using, I had suggested, the piece and polygon to use a mean of the surrounding data, the surrounding station, to actually use it to fill in those gaps. So this is just the beginning of our investigation on what is happening locally when it comes to the rainfall data. So yeah, I will definitely move forward with that as the study still continues.
We've got 2 minutes. There was one more question, is it? There. Can we get it quick? Well,
Thank you very much for position. My question was basically around, well, I think everyone is just questioning the essential missing logic.
Yeah.
I think mine is also there. Would you all consider the integration of data for different databases like your source and your part, and at the same time there's also satellite data from NASA power also. Maybe instead using those data alternative and maybe doing comparison and just to see the results you got from your study. It's kind of giving you some results.
Thank you. So this is a part of my study for my master's, and this is where we're starting at. This is a conversation starter, and with the idea that you just gave me right now, I will definitely incorporate NASA's data and also the satellite data to just look at what Mary Jane had been doing with the data, that the presentations that she had given. It's something that I want to move into. I want to move into modeling as well. And so this is like I said, it's a starter, and I appreciate what you just commented on right now.
thank you. Okay, thanks very much. We have 3 presentations until tea time. Next, I've got on my list is Caitlin. That's Caitlin. Hi, Caitlin. Then I want to remind you that after tea we have the panel discussion, and we really want your input. But also we have one more presentation after tea, which I guarantee is going to be the most exciting, interesting after your time. Thank you, Caitlin.
Good afternoon, everybody. I'm Caitlin Johnson. I'm a lecturer at the University of KwaZulu-Natal and a long-suffering PhD student hoping to submit to the next couple of months. It's not a joke, guys. So my research is focusing on the estimation of extreme rainfall events and the development of methods to account for non-stationary climate data in those design rainfall estimates. Just a brief overview. I'll discuss very quickly the National Flood Studies Program. I'll give you an introduction to my research and the motivation behind it. I will summarize the methodology, discuss a few findings, and then what work still needs to be done in this research field. So the National Flood Studies Program was initiated by the South African National Committee on Large Dams and the Water Research Commission. They formed 4 working groups in 2014, focusing on rainfall, flood, hydrological data, and products used for flood estimation, and they identified the research areas that were needed within those working groups. Approval in principle for funding for the research, but the money didn't show up. So we just continue to do the research within our research institutions, and it's a multi-institutional program. And annually, there are workshops which we update the developments and reprioritize what needs to be focused on in terms of researching in floods. So the methods for design flood estimations in Africa, most of these, as you can see, were developed before 1990s. Most of them actually were done in 1960s, 1970s. And since then, we've got over 40 years of additional data available, as well as the development of methods internationally that we need to catch up with. To date, there have been some developments, but most of the work is still in progress. The work that I'm focusing on is design rainfall estimation. So my PhD work is in two parts. Firstly, looking at estimating extreme design rainfall events, and this includes the probable maximum precipitation, as well as design rainfalls with a focus on return periods greater than 200 years, and then incorporating non-stationary data such as that due to the changing climate in those estimates. The National Flood Studies Program identified those areas as high priority research areas, and of course, it's because the consequences of those estimates have significant impacts on the existing hydraulic infrastructure, the design of new infrastructure, and this has impacts on the economy, the environment, and as we have all seen recently, there's an increasing number of people that are now vulnerable to the disastrous impacts of flood events. So I'll talk about the probable maximum precipitation. Not many people know about it. And the definition is it's the greatest depth of precipitation that is possible for a given duration at any given location at any point in time. However, this estimate does not take into account any changes or trends in the climate. It's of utmost importance to have accurate PMP estimates because it's used to estimate the probable maximum flood, which is used by our engineers and hydrologists to define height of hydraulic structures. For example, a dam located upstream from a populated area. And this is important because we need to maximize the safety and reliability of these structures. So in South Africa, the only available guidelines to estimate the PMP were published in 1972 by the Hydrological Research Unit. They used 30 years of rainfall data from over 50 years ago. And since the publication of those PMPs, a number of severe storm events actually occurred which exceeded those PMP estimates which had been used to design hydraulic structures. So this tells us that they may no longer represent the upload of extreme rainfall in many parts of the country. And due to limitations in the methods used in that time, such as the inability to take into account atmospheric moisture, those estimates may actually be subject to as much as 25% error. So using the World Meteorological Organization approach, I used the extreme rainfall events were selected as the maximum of the annual maximum series for over 1,400 stations in the country. And then the moisture maximization ratio was applied to these estimates to maximize the atmospheric moisture of those events. Those were at-site events, so they were then transposed to ungauged locations, and then enveloped and smoothed to develop PMP curves or maps. I actually developed a 5x5 kilometer gridded database and this map, which gives us the updated PMP estimates using the more recent data. As you can see, of course, along the East Coast, that's where we see the greatest PMP depths. So just a summary of the important findings from that aspect of the research. 80% of the new PMPs that were derived using the World Meteorological Organization generalized estimation method are greater than the HRU estimates. There's an average of 2 times greater, but as much as 5 times greater in some cases. The blanket HRU approach, which tells us that a PMP is applicable across an entire region, either under or overestimates PMPs, as compared to this method, which firstly looked at site estimates and then transposed them across the country. The maximum rainfalls used in this study actually occurred after the publication of the HRU PMPs. So many of those events were actually not even taken into account in the previous studies. And this shows us the impact of using updated records in these types of estimations. And in a few instances, it was possible that the sandstorm events were used in the HRU study and the study. But still, the new estimates are greater than the HRU estimates. And this is probably because of the methodology used in this study as compared to the previous work. Then in terms of the high return period rainfalls, in South Africa, we have estimates for short durations and long durations up to the 200-year return period. And that was used data up to the year 2000. Unfortunately, we didn't have access to any further data records. So still using that same database, the extreme value series that was selected was the 1-day annual maximum series. And using the frequency analysis approach with LH moments instead of regular L moments. The LH moments were used because they better fit the upper tail of the distribution as compared to L moments, which tend to give undue favor to outliers. And using that together with the generalized extreme value distribution, the outside estimates were derived for the 200 to 2000 year return period. And then those estimates were regionalized across the country to ungauged locations using the geostatistical methods. I won't go too much into the stats and the methods behind this. So in the same way, as the PNP maps were derived for the different return periods, and just here to show you this is just an example of the graph of the LH moments, where we can see that LH naught here is the regular L moments, and each of these are the shifts of focus on the upper tail of the distribution of the various LH moments. And we can see here towards the high return period, the regular L moments often tend to overestimate the high return period, which is why they've never actually been used to estimate high return periods with confidence and accuracy. Another point to mention is the PNP is meant to represent the upper limit of extreme rainfalls, meaning that there is no quantity that could exceed it. But here we see the PNP estimate for this location in Mount Edgecombe, showing the old PNP and the new PNP are exceeded by about the 1 in 600 year rainfall. So this raises the question, should we be designing using high return period rainfall events, or should we be focusing still on the PNP? And in the dam design industry, there is a shift to focus more on high return period rainfalls with an actual return period value attributed to those events instead of just an upper limit. So I also did a comparison of the high return periods to the PNP, since the PNP is supposedly not exceedable. And we see that about 10% of the PNPs are less than or equal to the 1 in 500 year, and about 12% are between the 1 in 500 year and 1 in 1,000. So still a bit of uncertainty there. And then going into the non-stationarity aspect, we all know the story about climate change, increasing greenhouse gas emissions are linked to increased global mean temperatures, which are then linked to changes in extreme weather events. South Africa has seen its impacts of climate change. The mean annual temperature has increased more than 1.5 times that of the global mean. The frequency of extreme events has increased in parts of the country, but it's decreased in others. Overall, the annual maximum rainfall has been shown to be increasing. And these changes and other changes are predicted to continue into the future, though we can't be sure to what extent. So all of these previous studies on estimating extreme rainfalls and extreme floods are based on the assumption of a stationary climate. However, we know that this is not a realistic assumption, because we have seen evidence of climate change and evidence that the changing climate has impacts on extreme events. So we need to develop methods to account for these trends in extreme rainfall events in this non-stationary environment. Internationally, there have been a number of studies in most recent years that are actually exploring estimating non-stationary design rainfalls and design floods. Africa can't afford to fall behind. So this is just the brief methodology of the work that I've been doing. And the idea is to use data from the downscale GCMs to identify extreme events, extreme climatic event types of climate drivers, which may drive extreme rainfalls. So at a local scale, an example would be changing temperature. At a larger scale, we'd be looking at some climatic event like the El Nino and Oscillation Index, the Indian Ocean Dipole, and so on. So the idea here is to use non-stationary extreme value analysis, in which that takes into account the covariates or the climate drivers. And here's just an example of the GEV where this changes as a function of time. So these are just the parameters of the GEV. And this changing as a function of time could be changing as a function of a covariate as well. These are then fitted to the daily extreme rainfalls. And then the exercise will then be performed again for using future climate data. And this is done to establish ratios of the future estimates to the so-called present day estimates based on non-stationary data in order to develop climate change factors which can be applied to present day estimates in order to design the future. So this is just a small case study looking at the non-stationarity in the eastern parts of the country. The reason this site was chosen was, of course, most recent years, we've experienced significant extreme rainfalls, but also the availability of data. So for this study, I've used data from the African Sugar Research Institute because they have daily data that is freely available on their website, and acquiring data from other sources up to this point has been challenging. So we've got 39 stations with at least 40 years of record, and most of them are up to the year 2020. Then in terms of covariates, first and foremost, we want to establish, is there non-stationarity over time? Is the data actually changing historically, and would it change into the future? And then NOAA has data available for the Southern Oscillation Index, Indian Ocean Dipole, and other climate variables. So this is just the preliminary findings for one of the stations in the southernmost part of KwaZulu-Natal in Hibadini. Here in figure A, we have the stationary case. So this is the typical case that we would do our design rainfall estimates. In figure B, we look at the non-stationarity over time, and C and D have different climatic covariates. Here we've got CO2, and that's used to represent change in temperature, and the dipole mode index, which is the Indian Ocean Dipole. Now, just by looking at the figures, it is difficult to tell and quantify the level of non-stationarity. And it just at a glance, it actually looks like everything is pretty stationary. But if we look at actually estimating the return levels for the rainfall using those covariates, we actually see how it could possibly change when we're coming up with estimates for the different return periods. So firstly, looking here over time, we see that if time is the variable, the line seems pretty straight across for all return periods, but there is a slight increase over time, just looking at what the return period values would be as time changes. The same can be said for the carbon dioxide. But the most significant change that is observable just by eye is looking at the dipole mode index, where you can actually see how the return period value would change as the dipole mode index value changes. So this is just work that I've done for one-day estimates. We revised the one-day PMP, done the one-day extreme design rainfalls, and looked at the one-day non-stationarity. But we still need to update our current database to be able to do short duration events, multi-day events, and then also to be able to determine the impact of non-stationary data on all of those updated events, as well as the updated PMPs. We currently have a project that is running that's funded by the WRC, which is focusing on developing a toolbox for non-stationarity and the application of that within design floods. And this toolbox is aiming at being output that practitioners and researchers can actually use in the design, to design for the future.
Thank you. Okay, are there any questions? I have one over here. And another over there. We'll take two, those two. And then I have a question if you have a spare moment. Go ahead, please.
Thank you for a lovely presentation. I was just interested, so you said you use future climate data and use downscale GCMs. I was just interested as to which downscale GCMs you actually use and which scenarios to be considered in your work.
Thanks for the question. At this stage, the work that I've shown is just based on historical data, observed data. So the idea is to identify the climate drivers and then use that information to extract specific information from the climate models. So we are in communication with Dr. Piotr Wolski at CSAG at UCT, and they, I believe, are using the CCAM models.
Okay, and I assume they're statistically downscaling their models, right?
Yes, yes. So that they will be statistically downscaled to a specific covariant or climate variable. So at the moment, they've got the overall model that covers the whole country, but if you want to have a specific downscale model, you need to know what values and information you want to extract. So that's what we're trying to establish here first.
Okay, and then so if you, in your planning, which scenarios would you consider and how and why? I would just say, like, why are you having that would be. Thank you.
And when you're referring to the scenarios, or you're referring to the climate model scenarios, or
Is it the scenarios like
yeah. Okay, so please understand, I'm from a civil engineering background. This is a multidisciplinary topic, so we are relying very heavily on support from the climate guys at CSAG to advise us on the way forward there.
Let's take the second question.
Thank you for a very good presentation. How important do you think is to get observed weather data for the last 20 years for the country, for your work and for dam design into the future?
Thank you, Steph. It's, I don't want to sound cliche, but it's very important that we have the most recent up-to-date data, because just looking at the impact of extended reports, just looking at the PNP, for example, where we see the last estimates were done over 50, 60 years ago. And since then, the data reports are showing that so many extreme events have occurred that we need to account for in our future designs. So how will we be able to do that, giving us accurate and up-to-date estimates if we don't have the most recent historical data? And this is also a point to note going into the future, that we need to be continuously updating those reports so that every time there is an extreme event that occurs that's outside of the norm, that's then taken into account in the next estimate that you're going to be designing for going forward in the future.
I just want to finish off with a comment about how important this is, because if you take Durban as an example, there are still people without water, right? And this might not be a dam design or a bridge or in cases, it's all infrastructure. And it's not just the precipitation, it's also the runoff and the management of the runoff and the design of drainage and all of those kinds of things that have to be designed to with the capacity to handle extreme events of this nature. So this work is really very important and something which I think we should make sure is not, that engineering design is not lost to the story. So thank you very much. Okay. We're moving on. We have a few more talks until tea time. Hang in there, guys. We've come a long way to be here together. So I know it's tough going, but hang in. So this one. So Wanjiru is from UCT, and I'm also telling you to be claiming her as an access student originally. Right? Okay, so all yours. Thank you.
Thank you. So yeah, I'll be talking about the KZN plans that happened last year in April. And we've had a lot of good information about them earlier this morning, but I'll just maybe add a few points. So yeah, this was the cutoff flow in the SARS warning release. It was said to be linked to a cutoff flow. The flood was said to be linked to a cutoff flow. And some stations recorded over 300 millimeters of rainfall. Just this is in a 24-hour period. That's a lot of rainfall. And there were over hundreds of deaths, tens of thousands of people were displaced. Extensive damage was done to property and homes. So this was a national state of disaster that was declared by the president. But I'd just like us to look at the flood history of KZN. This is a comment that was made that this flooding event is a weather phenomenon that is unprecedented in the history of our province and perhaps that of our country. So this isn't exactly true if you just look at the actual rainfall amount. And these are historical records from an article we got. And daily, in terms of daily rainfall amounts, in May 1905, 398 millimeters recorded at a station, August 1968, 255. So we already see that's kind of comparable to the recent flood. And then during a 3-day period, 650 millimeters of rainfall, that's April 1856. And then more recently, 1987 in September, and this was also related to a cutoff flow, 800 millimeters of rainfall in 5 days. And just to put that in context, 800 millimeters of rainfall is like the annual average of the coastal KZN region, roughly. So yeah, this wasn't exactly unprecedented in terms of the amount of rainfall that fell, but why it's still important to just understand the event is because the circulation patterns that are responsible for heavy rainfall events, they vary from event to event, the distribution of rainfall. And this pie chart here just shows the weather systems responsible for the top 20 events in northern KZN. And we see the MCS features there, tropical storms, tropical cutoff flows accounted for the greatest number, and then we have the tropical extratropical cloud bands. And so we will see some of these systems feature as I go through the talk. And then just another note is that the floods were unusual in this regard. Cutoff flows mainly produce rainfall in KZN in early summer, so that's October, November. But then this flood occurred in April. So that's one unusual feature of the flood. And then also it occurred during a protracted La Nina episode. And what that means is that we've had consecutive seasons of La Nina, and this is a very rare occurrence, the first time this century. So, and I think it's actually not just 2022, I think it's still present. We are still in this protracted La Nina episode. And this is around the same time we're having floods in the eastern coast of Australia. So these are two important features of this flood. And for the study region, we looked at the coastal KZN because this is where some of the heaviest rainfall was recorded. And we also got some data, data of the Mozambique Observatory. And I'll just break this talk into 3 main parts. One, we look at the distribution of rainfall along the coast from the 10th to the 12th of April. And then we look at the synoptic background and then the evolution of some mesoscale weather systems that influence the distribution of rainfall. Okay, so this is station data. And just as a note, if I say rainfall is on the 10th of April, it's actually a 24-hour period that starts at 8 a.m. on the 10th of April. So it will include part of what we would consider the 11th. But basically what I wanted to highlight here is that on the 10th of April, we observed Botswana in red and Richards Bay having a lot more, having heavier rainfall compared to the stations further south. And then on the 11th of April, we now see that the northern stations have less rainfall and the rainfall maximum has moved to the southern stations. And likewise on the 12th of April, then it's further down just to the 2 stations there, Margate and Port Edward that had over 100 millimeters of rainfall. And this is just ERA 5 data at 6 hour intervals. the accumulated rainfall in 6 hours. And we also looked at different data sets, but I'll just show you at era 5. The only data set that didn't do well is CHERPS. But we looked at CMOP, IMAG, etc. And what we see here is the same thing, that there is this southward progression of the rainfall maximum along the coast of KZN. And there's also a secondary maximum just off the coast of KZN. Okay, so the synoptic background, we know about the cutoff flow, but this is low-level geopotential height contours and moisture flux. And what we observe is that there's this zonally extensive, more than average, anticyclone. And at the northern flank of this anticyclone, that's where we see the strongest moisture flux. And if we take a transect of that, and then plot vertical velocity, what we see is that there is this strong low-level easterly flow. And that's just coming right into the coast of KZN. That's typically, that flow might be more southeasterly, but here we have it just directly hitting the coast of KZN. And so this jet varied in its position, but roughly it was centered along 27.5 degrees south. So that's another important feature of this flood. And then now we look at some mesoscale features. So this is a timeline where we see some important things. So here we see in purple that we have this very cool brightness temperature. This is a mesoscale convective system. And you can see just at the coast, it's hugging the northern KZN region. And then at 9 on 11 April, now we observe that the MCS is starting to migrate a bit further offshore. But then we have this meso low, and this is what Francois talked about, the subtropical low. It's the same system. I'm just referring it to its as a meso low because of the size, right? And here at the same time, I just wanted to show you the geopotential height contours. So there was trapping, and then now we have the first closed contour at around 9. So there's a low pressure system along the coast of KZN, and it's southward migrating. And then finally, at midnight on the 12th of April, we can see that the MCS has moved even further offshore and slightly southward. And so so I want us to look at how these mesoscale features influence the position of the jet and the moisture convergence and uplift. So earlier, when the MCS was closer to the northern coast, this kind of matches the time where there was low-level moisture convergence in the north. And that was the same day that we had the northern stations, Botswana, Richards Bay, having quite a lot of rainfall, at least compared to the southern stations. And then later on, as we have this troughing near the coast and a trough develops, a coastal trough develops, then moisture starts being diverted away from the northern stations, away from northern KZN and towards the south. And that's where there's greater moisture flux convergence and uplift. I haven't shown uplift, but it matched the same, it was kind of in the same areas. And this is when we had Virginia, Franklin, Huntington South having over 300 millimeters of rainfall. And just to quickly look at the sea surface conditions, these are relative to the April climatological mean. What we observe, we have positive sea surface temperature anomalies off the coast of KZN, mainly towards the south, the southeast. And then we have the latent heat loss was enhanced across this band in the southwestern Indian Ocean, this very extensive band. And this is, as we saw at the northern flank of the anticyclone, there was this long easterly fetch, and that matches roughly the region of the enhanced latent heat loss. So it's likely that the air was moving across this region and taking up moisture. But just to confirm that, we looked at moisture trajectories using HySplit. And what we just did was backward trajectories on all days, and then we did it backward 8 days. So actually what's in red is like the more recent, closer to the dates of the actual rainfall. And that's why I'd like us to pay more attention. So the brighter the colors, the yellow, the greens, that means that up to 80% of the trajectory is tracked through this region of enhanced latent heat loss. So it's likely that they'll take up most of the moisture there.
And if you look at B, the more the blue, the darker blue indicates a greater uptake of moisture because that's when the air particle increased in its specific humidity content. And we can see like sometimes it was losing moisture, sometimes it was decreasing in specific humidity. Other times it was increasing, but the darker blue indicates when it was taking up the most moisture. It's still over this region where there is enhanced latent heat loss. And okay, and just to compare to the mean, the climatological mean, then the latent heat loss was much greater and the moisture flux was much smaller. Okay, so I have a schematic that quickly summarizes what happened. That we have convergence through the Makutu, so it was Botswana, Richards Bay. We have this MCS that now starts to move offshore and slightly southward, and it influences the position of the low-level jets, such that it's not now directly hitting the coastline, but it begins to divert moisture away from the north and towards the south. And we have the migrating low. So in summary, yeah, the synoptic conditions were conducive for the formation of rainfall, but with regard to the southward progression of the rainfall maxima, we observed that it's these features that interacted with each other, produce patterns of uplift and low-level moisture flux convergence, and hence heavy rainfall. And to acknowledge this kind of interaction between this flow and the MCS has not been observed before in the southern hemisphere. And so it's just always important to be able to identify the systems responsible for heavy rainfall events and how they differ. So just, I don't know much about, I can't say much about like is this an effect of climate change, but just some things you can think about. It's number one, La Nina events are expected to increase in terms of the number of La Nina events that we'll have. And we know that cut-off flows tend to occur more frequently during La Nina events. So what might that mean for KZN? Another thing is if we have more La Nina events, that obviously influences sea surface temperature anomalies in the southwestern Indian Ocean, which is an important moisture source for KZN. And then also research suggests a general increase in the frequency of MCSs. This is just globally. I don't know much about the southwestern Indian Ocean, but it's something to consider, especially because this MCS occurred in April which is not the month during which the highest frequency or the highest occurrence is. So yeah, these are just some key things you can consider, given that it's the global change conference. And we did publish this work, so you can check the article out. Thank you.
I'm going to start questions with this question. So at the end, you said to our knowledge, this congregation has not been observed before. Does that mean it's not been observed or it has never happened before? In other words, what I'm asking is it by virtue of lack of observations that we haven't seen it, or is it really something novel? And then I have a follow-up question.
I think it just hasn't been observed. I don't think this is the first time it's happened, at least globally. And this was kind of one of those, oops, we found this when we looked at certain things, or when we're looking at rainfall. So for example, the rainfall that we're calculating was from midnight to midnight. But when you look at it from how source calculates rainfall, that's when you realize that there's this southward progression of the rainfall maximum. So I'm sure that's something else.
Yeah, I mean, this is probably going to be one of the best studied storms in history. So there'll be a lot to discover. And then maybe we'll go back to other storms and see some of those features. So my question to follow up with is, so now you've had a good look at these mesoscale interactions, which are interesting and at least novel from our perspective. What does it say about prediction? Can you use this in any way to help us with prediction?
I think I'm not a person to ask, but I'm sure if we could hear from someone else during the session later on, who would work with models.
Okay, that's fair enough. Any other questions, Carl?
Probably do.
No, I get to go on, otherwise it can't be early.
Thank you very much. I'd like to start by commending you on the slides. I think It's the first talk in this session where I've been able to read the labels on all of the charts, which really helped me as a non-climatologist to be able to follow and understand what was going on. I wanted to just pick up on one of the things that you said at the last. Again, I'm a chemist, I'm not a climatologist, and having read about this fascinates me. A few years ago, we had a series of really strong El Nino events. And in the popular press, that was continually linked to climate change, saying in climate change, we're going to have a permanent El Nino. And this is exactly what we expect to see in a warming climate. We've now had a couple of years of La Nina, and suddenly I'm reading in the press, well, in climate change, we're going to have a permanent La Nina, and this is exactly what we expect to see in a warming climate. Which way around is it? Can you clear that up for me? Or maybe somebody in the room can help.
So when it comes to what we've had, we know that it's a rare occurrence to have this, they call it a protracted La Nina phase where you have consecutive events, and that's the first time we've had it this century, but it's just a rare thing. Maybe we are just happen to be alive when it's occurring. So I wouldn't necessarily attribute it to climate change, but other researchers have said that we might expect an increase in the frequency of La Ninas. I don't know if they'll be the consecutive kinds, so that I'm not sure. Maybe someone else can get that up.
I think this is a point of discussion for later. It's a good one.
Yeah.
And it's similar to something I wanted to ask Charlotte when she spoke earlier this morning, where we've seen these maxima being reached, these new records being reached. I don't think we see record minima, but we certainly are seeing, not in South Africa, we're seeing record minima in other countries, at least a seasonal minima. And the question is what we're seeing just a broader range of variability rather than a sort of change in average? Or was it both? But that's not for now. Unless you really want to answer. Want to answer? No, okay. Good. I think we need to move on to our final talk before tea. If we may, thank you. Thanks very much. And we have got Nicole. Okay, so Nicole, the floor is yours. Thank you.
Good afternoon, everybody. My name is Nicole Loader. And the project that I'll be presenting to you today is actually an honors project that I did last year. And it focuses on the spatial temporal analysis of heavy rainfall, summer rainfall across the Free State Province from 1981 to 2022. So I'd like to just note that over South Africa, short-lived heavy rainfall events are predicted to become more frequent and more intense. However, this does not actually occur uniformly across South Africa, and the timing thereof also differs. For example, summer period projections generally depict an increase of frequency and magnitude of short-lived single-lived events across the eastern and central parts of the country, whereas the western regions don't show the same. The increased probability of these frequency magnitudes of heavy rainfall events could have huge implications on crop damage, infrastructure and properties, as well as actually being a threat to human health. So the focus was the Free State Province, and this province is actually considered a very agricultural important province that relies heavily on rainfall. And it benefits greatly from understanding the trends in heavy rainfall events and how they relate in relation to the elements of oscillation. And so as the threat of anthropogenically induced warming becomes a long-term concern, it is vital to explore the impact thereof on rainfall, especially on heavy rainfall events. Therefore, the aim of the study was to analyze spatial temporal characteristics of heavy rainfall, heavy summer rainfall, so from October to April, across the Free State Province. And this was done with 3 objectives. The first was to calculate and examine the characteristics of frequency and magnitude of heavy rainfall events. Then the second was to quantify trends in heavy summer rainfall characteristics. And then the last was to explore the influence of ENSO on heavy summer rainfall characteristics. So as I said, The province that we chose was the Free State Province, and this province is located on the Highveld. It has a varying elevation from 1,800 meters in the east to 1,200 meters in the west. It's mostly semi-arid province with an annual rainfall ranging between 300 and 900 millimeters, following the east-to-east gradient, with the eastern region being wetter than western regions. And as I've said before, it's an agriculturally important province and is considered a breadbasket of South Africa, and so it produces much of South Africa's crops such as sunflowers, beets, maize, sorghum, and so forth. So for this study, we used CHIRPS, the Climate Hazard Groups Infrared Precipitation and Station data, with a resolution of 0.05 degree, which used for rainfall data, and this spanned from January 1981 to April 2022. Along with that, we used the Oceanic Lunar Index to identify our lunar phase summer seasons. And this was identified with on average values, summer values from larger than or equal to 0.5 or smaller than or equal to 0.5 respectively. So we used 4 heavy rainfall indices from the expert team on sector-specific climate indices. And these were calculated to quantify the magnitude and frequency of heavy rainfall. The first indice that we used, index that we used, was the R10 millimeter, which refers to the number of days that we see at least 10 millimeters of rainfall. The second was the R20 millimeters, which was the number of days that we see at least 20 millimeters of rainfall. The third was the R1 day, which was the maximum 1 day amount of rainfall, and the last one was the R5 day, which was the maximum 5-day amount of rainfall. So the indices were calculated on a monthly scale, and then they aggregated annually for October to April summer months, and then they were averaged from 1981 to 2022. Thereafter, the trends were calculated using a non-parametric Mankin-Down phase test along with the same slope to quantify the rate of change. The statistically significant level of 5%. And then finally, to explore the ENSO influence on the rainfall characteristics, a composite mapping approach was used to isolate El Niño and La Niña phase summits. So the first results I'll be discussing with you is the mean results that was calculated. And on average, you can see that the eastern region received were characterized by the highest magnitude and frequency of heavy rainfall events during the summer wet season. And so across the eastern region for the R10 millimeters index, up to 4.5 days were characterized by at least 10 millimeters of rainfall, while the western region showed up to 1 day, receiving only 2 millimeters of rainfall. The R20 millimeters showed a similar spatial pattern, however, the fewer days that actually met was at least 20 millimeters of rainfall criteria, with up to only 2 days in the eastern region meeting this criteria. For the R1 day, the eastern region again received on average 25 to 30 millimeters of rainfall. The central region received 20 to 25, while the western region received 15 to 20 millimeters. And then on the 5 day, eastern region again received the most, which was 40 to 65 millimeters of rainfall, the central region 35 to 40, and the western region received 25 to 35 millimeters of rainfall. So as I mentioned, we used the ONI identification to isolate the following year, phase years for the composite analysis. So I'm going to separate the discussion on ENSO. The first I'm going to discuss the R10 and R20, and I'm going to do this first El Niño phase and then the La Niña phases. So the El Niño phases, the R10 millimeters, just predominantly negative anomalies during the El Niño phases, and then with the R10 millimeters, it showed up to -6 days that were characterized by at least 10 millimeters of rainfall. The 20 millimeters index showed predominantly negative anomalies of up to the negative 4 days. That we see that these things. Now for the La Nina phases, for the R10 millimeters, positive anomalies of up to 5 days receive at least 10 millimeters of rainfall. And for our 20 millimeters, index up to 4 days receive 10 millimeters of rainfall. Again, the same process just for our 1 day and our 5 day. During the La Nina phases, the negative anomalies that we see in our 1 day show up to negative 5 days, negative 5 millimeters. For our 5 day, there was a similar spatial pattern, however, it was up to negative 6 millimeters, which was evident during the La Nina phase. For the La Nina phase, positive anomalies were seen in our 1 day of up to 5 millimeters, and for our 5 day, it showed up to 7 millimeters. So lastly, for the trends analysis, for the R10 day, predominant increase in trends of up to 0.4 days per decade were detected with statistically significant increase in trends mainly seen for the northeastern and western regions. For the R20 millimeters index, decrease in trends of up to negative 0.1 days per decade were calculated, with few statistically significant trends for the regions scattered across the central region of the province. For the R1 day, the decrease in trend, predominantly decreasing trend of up to negative 2 millimeters per decade were evident, with smaller areas in the central region again showing statistically significant trends. For the R1 day, predominantly decreasing trends were seen for the of up to negative 3 millimeters per decade. The statistically significant regions, statistically significant trends evident in the central regions, and then finally, the R5 day. And then there were increasing trends seen as well for this index of up to 2 millimeters per decade in the western and eastern regions, which is statistically significant. So over the preset articles, it's evident that from these results that they reflect that the eastern regions are experiencing a higher magnitude and frequency of heavy rainfall as during the summer and late seasons. And now these different ENSO phases also influence the heavy rainfall events, patterns, and the results show that we have a deviation from the mean pattern of rainfall. So the La Nina phases show above normal conditions, while the El Nino show below normal, which is consistent with what we've seen in literature. And now, since the current La Nina phase is actually still ongoing, the entire province is likely to be more vulnerable to high magnitude and frequency of heavy rainfall events, especially during this current summer season. And these results also highlight vulnerable regions that are more vulnerable to flooding, especially during the current and also future general La Nina phases. Summers. For the trends analysis, the R10 day showed an increase in trend, whereas the R10 20 millimeters did not. The R1 day showed a decrease in trend, but the 5 day did not show a decrease in trend. Not the same. So this implies that heavy rainfall events are increasing. However, very heavy rainfall events are not. So those are exceeding the 4 millimeters of rainfall. So as future projections predict possible increases in these future heavy rainfall events, frequency and intensity of heavy rainfall events, statistically significant areas in the northeast and western regions are considered vulnerable to these increasing trends. I think more flooding events could occur in these areas. And then should heavy rainfall events actually occur more frequently and intensely, this could actually magnify those implications I mentioned earlier. This could increase, could intensify crop damage, damages to structure, damages to properties, it could increase spreading of diseases, and that are persisting at the moment during the rainfall. For example, in early November 2020, there was a heavy downpour that occurred in New Zealand, and during which many people died, and numerous were rescued from flooding properties, and even damages to infrastructure was caused during this downfall. So at the end of the day, at the end of this project, it's noted that the Free State province is vulnerable to variation in the frequency and magnitude of heavy rainfall events, with higher vulnerability during La Niña phases. And then lastly, the province is also vulnerable to increase in frequency and magnitude of these events, which then highlights that adequate preparedness and response strategy are needed for vulnerable regions. Thank you.
I have a question, but I'm gonna let you think about others if you have, and that is just to ask. So this is sort of like a central part that is not getting wetter. And then there's a western and eastern or southwestern and northeastern area side showing a wetting trend, right? Would those be as a result of different sources or different weather systems that are producing it? In other words, are you seeing sort of a change in cold fronts coming up from the Cape to explain the southwest, and then more tropical sourced rain in the northeast, or are they similar symptoms? Could you comment on that?
It was something that I looked at, but it was not a focus of the study. So
Okay, fair enough. There's a question, yeah, from Caitlin.
Thank you. Thanks for your presentation. I'd just like to know, why did you choose to use satellite data as compared to observed historical records? And since you have used satellite data, why CHIPS and not something else like ERA5? The reason I ask this is because CHIPS quite often has been found to not accurately represent the observed rainfalls. And how do you know that that is a good representation of the rainfall that actually occurred within the study area, and how does that impact your results?
thank you for the information. Initially, it's a thought that all satellite data, there are going to be limitations to what you're going to get from that data. And so it was also an idea to go with extension data. But in all honesty, the CHIPS data was presented to me as an option, and for an honest project, that but yeah, thank you.
So, I mean, I think what this speaks to is the idea that this is a really nice piece of information which can be used to validate other data sets or invalidate other data sets. So I think it's a very useful piece of work which can really be followed up on for that very purpose. Any more questions? If not, I'm going to release you. Thank you, but not you. Just stay here, everybody. If you want something. We have reached tea time, and I want to say we have reached tea time, right? Yeah. Okay. So after tea starting at exactly 16:05. Is that right? Something like that. 1600. Okay. Is a talk which is not about flooding and it's not about temperature. What?
5 minutes to 1600. You'll never get people in an hour.
Oh, sorry. Whatever, after tea. Okay. Is a talk which is not about rainfall, not about temperature, but about wind. Which makes it stand out, apart from the fact that I'm a co-author. So please, we do want to try and make sure that everybody comes back after tea, mostly because we're going to look at those questions that we want to get some discussion going here from the panel and make some decisions, hopefully, about what we can do as a collective. So let's break for tea, and I'll see you at exactly. What time do we start? 4:30. No later. Thank you. Next up. Yeah. asking somebody to come up the stairs, here they come.
If you want to do it in the style of a horse race.
HPW. Okay. All right, folks, we're going to resume our program for the day. And our final presentation today is from Will, who is going to talk about Willie. So the floor is yours, Will. Okay.
Good afternoon. I think this talk will be slightly different to what you guys heard, I think, most of the day. I'm not a scientist, with a scientific background. I work for CSIR as Coastal Engineering Reports Infrastructure Group. We do a lot of work with Transnet, TNPA, and port operations. So that's basically the background in the work as well. Okay, so this case study forms part of a greater investigation into extreme climate events and conducted in collaboration with Exodus and Levels Ethics Project. Good. So I'll first just give an introduction, background of the port and its operations. We focus on the fresh produce cargo, and then I'll discuss extreme winds in the port and their effect on operations. And then I'll just give a brief introduction to the mitigation strategies that we are working with. The Port of Cape Town is situated at the Port of Africa, well along the busiest trade route in the world, linking the Americas, Asia, Australia, Europe, and Far East. Modern global trade centers around shipping and the port industry, with around 90% of trade in the world handled through this medium. For this reason, the port receives a large amount of transshipment as well as import and export cargo. The main commodity of trade in the port is fresh produce, fruit, perishables, and frozen goods. For this reason, the port is also known as Africa's premium fresh produce port. Whilst being a notable leg in the global shipping and trade network, the port also plays a vital role in regional and countrywide economic stability. So just an overview of the port. Operations include handling of dry and liquid bulk commodities, fishing, ship repair, yachting, leisure vessels, and container handling, amongst many others. Its main export item, fresh produce or fruit, forms part of the container handling segment of the port, with operations mainly situated at the container terminal for the Benston and Basin. As the main export and import cargo, we make a focus on fresh produce and analyze its value chain. Shipping lines carry packed or empty containers to the port. Port operations are then responsible for moving the vessel into the port area until it's berthed at the terminal. Once at the terminal, terminal operations are responsible for loading and unloading of the containers from the vessel. Stevedores transport the containers along shipyard via trucks or RTGs. Once passed through customs and clearance, the trucks then transport the goods to the end users. A similar process follows for the export of these goods. The following graph shows us the exports or the number of containers that were exported or packed on a vessel during the 2020 and 2021 season. If we have a close look at the graph, it's divided into weeks, and the peak season for export is basically the summer months of the year. So right up here and into the beginning towards the end of March. So basically, Africa's premium fresh produce port is at its busiest and most critical
during the spring and summer months. Okay, so why is that a problem? The spring and summer months are also the peak windy season at the Port of Cape Town. The windroses here depict the frequency of the average wind speeds according to magnitude and direction, as measured over a 10-year period between 2012 and 2022 at the port's container terminal. These plots show that the spring and summer months have the largest frequency of intense winds, especially in the southeast and the south direction. That's just the overall plot, showing all of the data. The notorious southeast and south winds have been responsible for a significant disruption in the Cape Harbour cycle 12. Video is from March 2017, but more importantly, in this case, the extreme winds at the port caused significant delays in shipping, rough seas, operational delays, terminal cargo handling delays, and income losses. The more specific example, I show the terminal during a normal day of operations where winds are moderate, and during a wind-bound event where you can see nothing is happening. So this is just time-lapse videos that I took, basically sitting on the opposite end of the port, recording over a couple of hours. So the question here is, can we classify these port disruptions as extreme events? So we look at, we use this definition by Harris and others in a paper titled Biological Responses to the Press and Pulse of Climate Trends and Extreme Events, where they say extreme weather or climatological events can be broadly defined as infrequent, intense weather event, which is often relatively short in duration, occurring over a few days or weeks. In a study conducted by the CSIR, we looked at the average monthly wind speed trends at the port over a 10-year period. The average wind speed, as you can see, it doesn't change much over the 10-year period, and in fact shows a steady decline if you look at measurements made at 3 port locations. So averages don't tell us much about extreme events. There has, however, been an increase in the intensity of winds in the spring and summer months. If we look at windroses from the spring of 2012 as compared to the spring of 2022, we see an increase in the frequency of higher speed winds in the 16 to 18 meter per second range, as well as the 18 to 20 meter per second range, all of which are coming mainly from the south and southeast directions. So I just showed 2012 and 2022 here, but you can plot out all the figures, show you there's a general trend of this increase. The 20 meter per second range is important here due to container terminal operational pressure. Unfortunately, limited is set at 20 meters per second last year, and at 25 meters per second gust wind operations should be halted entirely. But we note here that the plotted figures are based only on averages and not customers. But even here, we can see that the winds are trending to disruptive levels. We analyze an extreme wind event to illustrate this impact further on container terminal operations. But firstly, we note the terminal operation safe working condition as introduced in the previous slide. Containers are loaded or offloaded from vessels using rail-mounted gantry cranes. These cranes have 2 environmentally driven operation constraints: ship motions or mission surge caused by long period waves, which we will discuss here, and high winds, which make a container loading inoperable and unsafe. For high winds, the crane limitations are set at 20 meters per second, which is the precautionary limit for gust wind speed, and 25 meters per second, at which operations should be halted entirely. These are based on the 3-second gust wind speed measured at the crane top level. A vessel, the MEC Lily, was scheduled to dock at the port on the 19th of December 2022, scheduled for 10 a.m. at the container terminal for loading and offloading. On its arrival, the terminal is in the middle of a series of extreme wind events. When it docks at around 9:30, the terminal has been windbound since about 6 p.m. of the previous day. So that's the terminal announcement. We're going through them just now. Okay, so this is a plot of the wind speed for 7-day period, during which there was 3 wind events. We analyze, or we see that the first event starts around the 17th, when the wind peaks above 20 meters per second. And the wind then subsides again the following day at around 8 a.m. You see the same trend for the second event and the third event. But now we look at how that actually affected the operations on that vessel. The slide also just showing us that all of the wind speed measured here had the south direction. So just illustrating that trend again, that all the disruptive winds coming mainly from the south. So during the first event, the port was closed for a period of about a day, from the 17th at 10 a.m. and opened again the following morning at 4:30. The vessel then arrives on the 19th. At the point when it arrives, there is a wind event that started at 6 p.m. the previous day. The wind then subsides, as shown in the previous graphs, but operations don't start in the vessel until about 4 p.m. that day. So when it arrives at 9, operations only start in the vessel at 4 p.m. This is mainly due to time that's required to recover the lost operation of the previous vessel on other vessels that are also damaged. So there were 3 vessels, it arrives, but they can't actually start operations in their vessel because they've lost quite a lot of operations time in the others. The third event then begins on the 20th at around 9 a.m. But we see that there has been some operation. Oh, it's not so clear, but basically, if it was a bit clearer, you would see here that it starts off at 2:49. The amount of cargo that's on board stays at 2:49, and then they start moving a little bit. But from this point onwards, they start operations on the vessel, and they continue right up until the following morning, the 21st. So if we sum all of that operational time loss, we see that just for the container terminal alone, we lost about 56 hours due to the wind events, and for the vessel itself, 23 hours. So the entire day of operational time loss, the vessel was just sitting. The port is 24 hours. So it's what you take into account. Okay, so in general, we want to understand how we can quantify the effects of this process. So how much are we losing money-wise, time-wise, during these disruptive events? The main point here is that fruit is a time-sensitive commodity. It can only be exported at a certain time and it can only spend a certain amount of time at the port. So delays result in spoilage, additional refrigeration and storage costs, as well as delayed delivery. 30% of this cost goes to the farmer. So what can be done? We would like to improve the port's resilience in terms of it handling or responding to these disruptive events. And I use this from Orsini and Barker to say the resilience of the port system can be associated with 3 main objectives: absorptive capacity, hazard awareness and reduction in vulnerability, adaptive capacity related to temporarily adaptation to maintain performance, and recovery capacity related to restore performance after disruptive event. So we use a 3-pronged approach. Firstly, we want to understand the local and regional and climatological drivers of extreme winds and the potential impact in the future. So how does the wind look at the moment and how would it change in the future? Secondly, we will address the economics and the social landscape of the Port of Cape Town's trade industry to identify all those affected from the Port Authority to port operators, shipping companies. And then mitigation strategies. What strategies can port stakeholders and port authorities reasonably employ given the known and forecasted dynamics and effects of streaming in the region? So more to the mitigation side, which is where I would like to be involved. I believe that time could really be saved in understanding the event, predicting it better, and recovering lost operational time during the event, in between events, and after and before. So I've overlaid the predicted wind speed value that the port had access to at the time. Clearly, you can see that the prediction trends similarly to how the wind acted, but doesn't peak at the correct point. So it doesn't peak when the high wind event occurs and when it subsides. So if we can work at improving these predictions, the port can obviously plan better, know in advance when an extreme event will be happening, and recover the lost time once it's subsided. So this is one of the solutions that we're considering for a single hoist tandem head block. Basically, it allows the port operators to load and offload containers at a double capacity. So during the times when there's a high wind event either predicted, on its way, or just passed, we employ this method to recover the amount of containers that couldn't be loaded during the disruptive period. This is obviously a costly implementation, and it's very high energy consumption, so it would have to be tempered. Use it only for a certain amount of time, for certain lessons, but it's part of the investigation. Good, thank you.
Thank you. Are there questions from the floor? I see Sarah's hand. You need a microphone. Hold on. Is there a spare one around? Oh, sorry. Okay, go here and then we'll go there.
And what is the lead time of that MC prediction?
By lead time, you mean?
How far in advance?
Oh, it's a 7 day.
Not bad.
Sarah was next.
No, I was going to comment on that. Basically, yeah.
Yeah, so we've got quite a lot of high resolution wind data from these service vehicles that we've deployed, also around the coast of South Africa. And I just want to say, like, Aero 5 actually did a really good job with the ones, but yeah.
Okay, thank you. Jen?
It's great time lessons. I really appreciated that we're seeing something more interactive this late in the afternoon. So a lot of what you're talking about is where our port's actions are prohibited because of what we know to be forecasted high winds on a given day or experiential high winds on a given day. But what are the experiences that perhaps when we think back to the Hearts Festival this morning, to what extent are we already experiencing or are we projected to experience quite significant loss and damage at a much more small and commercial scale, leading from unexpected wind events. So our unforecasted winds or our sudden change in wind conditions where we don't know about them long enough in advance to prevent port accidents. So we can talk about a lot of the economic losses of not being active, but have there been damages where a port or harbor continues to operate during high winds that are unexpected or where the wind changes the operation?
I think in my observation, it tends to be a jerk or knee-jerk reaction. So the port stops operations immediately when they measure the wind speed exceeding 20 meters per second. So I think there's perhaps from experience I've learned that the predictions sometimes underestimate, so they don't actually plan according to the prediction. And I think if we can motivate that the prediction actually tells you exactly where closely enough that you can expect these kinds of wind conditions, then I think they would be more reliable in the plan. From my observation, it's generally they stop as the wind bends, so they wouldn't continue to an extent where there would be damage or incident.
There's liability involved, so then they'll be very careful. I'm gonna ask you a question, to which I know the answer, but I'm gonna give you the opportunity to say. Other than high wind, what other limiting environmental drivers or factors are there in ports that matter? And is it just the crane operations that are affected, or the other processes that are affected by the wind?
Yeah, I think I mentioned the long waves, which cause vessel surge. Yeah, CSR has done a number of studies on that, but we will be looking at that. I just thought we focus on extreme winds for the sake of this. But long period waves cause surge, basically the vessel moves up and down at birth, and they came up into operations. Your second question was, does the wind affect other operations? Yes. For example, according to that value chain that I illustrated in pictures, for the vessel to come into the port, pilot boats need to go out and fetch it and navigate it into the port area. And the pilots who are in charge of that operation usually check the wind speed. And I can't remember what wind speed they work at, but they obviously need to know exactly what the wind is doing, mainly the direction, more so for them, but they also look at the wind speed to determine whether to the operation. And obviously at the land side operations, they usually stack the containers fairly high. If you have high winds, you have incidents with blown over. And of course, with flooding and such, we see what happened in Germany with their container terminals.
Thanks. It's also a sea state for the pilot transfer. In some ports, they use helicopters, but in helicopters can't fly in certain conditions. Right? So, and I think what's important to know is that the shipping lines are like a law unto themselves. They have a schedule, a global schedule. If they are held up because the port has a backlog, they might bypass the port, go to the next port, and then the goods that were meant to be exchanged at port A now have to be done at port B and have to go by road to do that. So they take fruit sometimes to Durban, which should be going through the port of Cape Town in circumstances like that. So economic impacts of increasing intensity are really, really important. And just to add one more thing, I'm sorry, I'm very excited about this project, is to say that we also have this problem in winter, not so much, but there are some winter storms that close the port, right? Yeah. And then there are other issues like fog, but they're smaller. Any other questions for Guido? One more, and then we'll move on. Sorry. One more to back. Well, Sasha will take you.
Okay, mine is. Thank you. Okay. I just wanted clarification. Are you saying that wind prediction is one aspect of mitigation strategy for ship wind?
Yes, but mainly for ship operation or containing, unloading, and moving the vessel in and out of the port. So we would like to improve the predictions that we have so that we can aid port planning basically.
Yes, Sasha, before you go, let me just say that also there are some wind shadows in Cape Town. So just on the other side, like Camps Bay, those areas, when the wind is blowing, pushing through, so there's a short inshore wind shadow. And there's a potential for getting pilot boats out there when there's high wind, for example, as a way to mitigate the fact that they can't board wherever else. But that is your point. Berthing is one process, operating and transshipment on another. Such a last quick one.
Okay, yeah, I missed the presentation, unfortunately, but this might be slightly so winds generate long waves. What is the effect of that considered in like the project control? And I'm just wondering, Do you know like any, like, engineering and something to make it find effective to practice waves in the areas trying, gas was installed and put the set house on the points and the machine, moving through it.
Yeah, so with waves, separately, I will be looking at, long period waves and how they affect, surge or vessels, burst. But I think in general, there's a lot of work that's been running in the engineering field. Yeah, basically that's one implementation, but there's a lot of work there, civil engineers mainly to protecting vessels that are coming into the port. So, yeah, I can chat to you afterwards if you want specifics. Share that with you.
Thank you. We are love to continue this conversation because it's very interesting, but we have to stop. So thanks very much. Okay, so now to the interesting part of the session, folks. So I'm not going to put anybody on the spot. We're just going to go row by row and we'll have to sing. I'm kidding. Now, what I'm going to do is, one of the things we want to do is to walk away with some kind of mandate from this conference to say, yes, we need to get organized, and no, we shouldn't, as the case may be. So the idea of this set of questions was really just to ask your opinions on what you think might be a valuable consideration. So we posed these three questions. What do you think is the most pressing research challenge, i.e. the scientific research question related to extreme climate events? And, you know, if you have more than one, that's also okay. The second question was, do you support the idea of some national regional scientific working group focused on all scientific aspects of extreme climate events? If so, why? If not, why not? And then why do you know, so who do you know, institutions, researchers, and research groups and other role players that should be participants in such a working group? And we've collected these, and I would like to collect them all, and I will collect them and prepare a report out of this session. And take some of the questions and comments that we've got, so we've got something we can use. And I'll send it to the conference organizers to make sure that everybody gets it. But I did want to give the floor an opportunity to kind of respond to these questions. So what I propose we do is we take some answers to that, and then I'm going to ask our members of our panel to come up and give their perspectives on some of this. So I'm going to try this. Let's see how it goes. It's really up to you guys. As much confidence as you have. For anyone who has got an answer to question number one, what do you think are the most pressing research challenges? And I'm going to just try to stimulate this question by saying this. Sarah made the observation at tea time. Was it Sarah? Yeah, it was you. That said, it's interesting that we've had a lot about rain and about flooding, right, in this session. And I guess the Durban floods have really stimulated that, right? But of course, we have extreme temperature issues. We had some conversation, some input about that, but we had nothing but drought, interestingly. Now, why is that? Is drought not an extreme event? Is drought different in the sense that it sort of comes on slowly? It's a kind of an insidious development rather than a sudden event, like suddenly it's drought, as opposed to like suddenly it's flooding. What's different about drought? And is an issue. And so that's what my kind of stimulus comment is. And I would like to hear if anybody has written down something on the card, what they think. In responsible, I said more about that, about the idea of legal priorities. But I might read some cards.
I just want to say it's quite funny because like during the drought, nobody was talking about floods. And now floods and the droughts are seem to be over and running out, and nobody's talking about it. So we seem to forget very quickly.
Yes, that's right. Okay, so who wants to volunteer some research priority? I've got livestock is responsible for 48% GDP. So we need short-term and medium-term warning systems for livestock in order to manage extreme events, colder and hospital and drought. That one. advance in our research projects. From being reactive to more active practice. Practice in response to climate change. I perceive that there is more focus on flooding. That way. Okay, so this duration, so this is about drought. Done. Okay, so let me stop there and see anyone wants to volunteer. I'm going to run around with the microphone.
Just to add that we need access to also the places that we present nice like that.
The inevitable question about access to data. So look, that's another whole topic. I mean, I don't think that anybody's under any illusions that access to data is complex, and it's definitely an issue which is quite clear in the minds of SAWS, I will argue, and that there's, I don't want to go down that particular rabbit hole, but you know, it's something which everybody's aware of, including SAWS, and are looking for solutions, because at the moment, SAWS can't give away their data. But again, that's a rabbit hole we can go rushing down. But let's just hear more about any research priority issues. Okay, I've got two there. Mark, you give the microphone over when you're done.
So I think most of these extreme events that we talk about, they don't happen in isolation. Influenced by either other climate aspects or non-climate aspects. So I think compound risks, cascading risks, all that kind of terminology that we see resonance in our C reports, but we don't have the research. So I think that's very.
We don't have, what was the last sentence? We don't have
We don't
the.
have the research to not back up, but to understand how they do interact.
So, okay, just let me just interrogate that a little bit. So the question is really about the research strategy or the research scope is not focused adequately on the range of issues pertaining to extreme events.
So, I mean, as an example, droughts, if we have droughts in the red baskets, say South Africa gets a drought, it affects all the surrounding countries in terms of food availability, food prices, changes, all those kind of things come together on top of maybe a drought within that country as well. So we have a lot of interconnected, the systems are interconnected. And what may be a sort of climate problem addition can be escalated by all these other issues, whether it's the war in Ukraine as well, driving the fertilizer prices this year. It's bringing all these kind of components together.
Yeah.
And we understand we need to do it, but I'm not sure there's that much research going on directly in understanding.
Okay, I know you have to leave the room, right? So I would go on, but I'm going to let you go. But it does speak a little bit to what Mary Jane was talking about, a sort of a unified model, which can have components like the war in Ukraine, as in a shortage of fertilizer or fuel costs or load shedding plugged in to those.
I didn't see Mary Jane's talk, but yeah, that's right.
Okay.
But just be a bit wary about expecting models to do this.
Okay. And Mark, I'm taking that you voted yes on this yellow card.
Yellow, yes.
Yes. I think it was Christian and then Jenny.
I think mine is almost anyone but it's also about the research. Listening to the presentations yesterday, I come to sense that there is much need to do about methodology, research methodology. So I believe maybe we can focus on that aspect, teaching students or helping students to understand how they can really choose the good modeling process that they come to do themselves. This is really should inform the policymakers framework. So if the method is not well chosen, the result will come to bias or looking like we have done. Statistically thinking, what we put there that will come there. So if your result comes like, significant, significant, because people, it's what looks big. But in reality, you chose the wrong method for this kind of research. So your research is not driven by the reality or by the parameters of the research. So this is what they will change.
Thanks. I want to respond to that before we end this. Just to say that, I just want to say that I mean, a lot of our thinking now is informed by applications. So I think it's really important. Look, there's model development, there's model understanding of climate systems at different times, like when you're looking at the user scale, for example, as opposed to, let's say, ECD looking at some attribution over long-term time periods. There's that question, which is more purer climate question, but then the application. And for example, in Vuyo's case now, where we have a real application, and that then directs the climate science in that application. So that's why we need this kind of end-to-end approach. So I agree with you, but what's right and wrong, I think, is case specific. Can I ask? Okay, we've got the microphone. Go ahead, then Jane, but nobody wants to speak.
Okay, thank you. And that's one of the dates to the moment. The presentation was so good, so high presentation, but I think what is making me go, we are much speaking quantitative. Where the first stage the model of digging from like quantitative research. So that even if you come up with the there's also inputs from other stakeholders or vulnerable communities. I think we are much towards only modeling. So what is happening is people want to say what are they extending? Only that we take really in depth recommendation to approve the
Thanks. Jen. Now I want to move along to the panel.
Yeah.
Go ahead.
Say this.
No, go ahead.
It is a response to the last 2 points, and I think that when we look at a sector-specific question and a sector-specific answer, as Neville's just been saying, when we do an end-to-end approach in a specific context, often those kinds of approaches do already exist and are already being used. So, for example, in the tourism sector, there are a number of multifactorial composite indices that include both quantitative and qualitative components that are built on the basis of tourists and tourism operators' perceptions and experiences in the climate. And that include not only ecological data, which they do include, and it is very quantitative and localized, but it includes a number of other components. So Mark was talking about how we need a broader scope, and those kinds of indices have up to 53 variables, including Gini coefficients, security indices, levels of transport and harmful mobility. And so these kinds of indices do exist, and I think that often when we're working clearly in a climate space, we're not as aware of what happens when you're dealing with specific sectors such as tourism, agriculture, shipping, and logistics and all the rest. And that many times those methods do exist. And so it's about engaging with people who are working in those places and understanding what kinds of tools they use, and that we can keep in our climate data and get moving the results.
Yeah, I mean, I can only paraphrase what you're saying, but I want to emphasize that it's important that we get a kind of a higher level view of not only who's doing what and what is available, but also that there's a synthesis. So I would like to reconcile Francois Isideen's and Wanjiro's studies and have them argue it out and tell us what is the consensus story here. What's the consensus about climate model? At least what can we use with a good degree of confidence? Okay, I don't want to keep us too long. There are yellow cards which answer the question, do you support this idea? And they are all yeses. Yeses, I agree. No nos. There's maybe a few yes buts. And I'm going to collate those, and I'm not going to discuss them now. I don't think that there's any disconsent, is that the word? What's the word? Opposite of consent is whatever. Negative views about the idea. Okay. And we've also got a list on the third question, which is who, so we can collate those to make sure that we can connect everybody. But I'm taking it from this meeting that we've got some really good ideas. The real important point here is about how to get a higher level of knowledge about not only what is being produced, but how to use the information at the level that is valuable for an operational application. And with that, I'm going to ask the panel to come up, and I want to hear from the panel. And we have got the panelists, 4 of them, and I'd like to give them some time and then some interaction with the group. So Charlotte is going to represent SAWS. Shingi is going to represent, you come up with your chair, please. Shingi is going to represent the CSR. Alina is there, and she will represent the FFE, and Jen has a volunteer time. Jen volunteered to sit in for it. So how we'll do this is for Apex. She's representing Apex. So we've got, you can put one of this, oh, that's too bright over there. Okay, better. So let's just say to you guys, I kind of briefed you. I said, let's have a point of view from you guys, both from your own agency and also from any responses that you may have. Does anybody want to start, or can I pick on you? No, I'm picking on Shingi. Shingi, let's hear from you, and then if there's interaction after the 5 of 4 spoken, we'll take it from there. Lights on, yes, and maybe camera off. Don't do that. Yeah, I mean the projector. We just no. Yeah. Okay. Ulus.
Yes, thank you for the and thank you also for inviting me to be part of the panel. I really appreciate it. So firstly, I would like to start by going to the first question. I don't say that.
I'm sorry. I'm going to give it to you on a piece of paper.
And I think it was about one of the areas.
Yes.
What do you think is the most pressing set challenge? For me, I believe that the most problematic area within Southern Africa, or within South Africa, is the issue of artificial intelligence. It's technical artificial. I think Francois mentioned it in the moment that we are having, as much as we are being affected by extremes in South Africa specifically, we don't have enough studies that are looking into artificial intelligence within the region, by scientists within the region. We are having a lot of studies that are being prescribed by probably the centers of Europe. But we have a lot of scientists within South Africa. And right now, Isdin was looking at this from Reptile, Francois, and also us, the CSR, we're also looking into these issues. But then, just also bring into the second question, we are looking at these things in silos. You know, we are not coming together. I think there's merit for us to come together, and even if we are to apply for funding, it's better that if we are having a group, we can get more funding than if we are working in silos. Right now, for us, within the CSR, we're looking at different extreme events which affect us not in the past 20 years. You find that in the literature, they said that there are about 190 hazards that were declared disasters. These were not small disasters, these were disasters that were affecting a lot of people in terms of deaths, in terms of infrastructure. So that's a big number between 2007 and 2021. That's a very big number. But then if you look at the attribution stuff that you look into this, actually, when you find that there is 1 or 2. So what we try to do is we looked at about eight hazards that are linked to the planting in droughts. One can ask, why didn't you look at wildfires or heat waves? But you find that out of all these 290 hazards, more than 70% of them, they were about plant stocks. And these were killing a lot of people in case they turn attacks and things like that. And those people look at 2021, they say that 2.7 billion of damage was caused by hydrometeorological disaster. That's 1 million. And if we can pay certain flood also billions of money. So we really need to come together and as scientists, CSR, SIOL, UCT, all of us come together and try to see how best can we approach this from a South and Africa perspective. And in Europe, I had a chance to work in Europe sometime. They have a grouping where they from different countries in Europe. And when an event has a strike, within a day, they gather be it online or in person. They start to see who can tackle this achievement. Within a month, they are publishing them. So we need something like that also in perspective of Southern Africa for this.
Thank you, Shingi. I just wanted, while you pass the microphone on, to say that we did have, for example, the gathering of scientists for the 2015-16 El Nino. You remember, and we had a gathering for the Cape Town Day Zero event. We had a gathering of the scientific community, but it's not systematic or organized. And I do agree that a division of labor is really important to establish. So thank you for that, Jen.
So I think I'll start by saying why I'm here, which is that I'm Willem Landman for today. I don't fit quite the same picture. But Willem is the PI on a project called APEX, which is an NRF ESSRP project looking at extreme climate events within certain sectors. And so myself, Neville, Hector Shakure, Nkaniso Mbata, Joel Batai, and Willem are working together on this. And we're looking across a number of sectors. So my work package is looking at climate health. We have work packages looking at fire. We have work packages looking at wind at the harbors. And we have work packages looking at methodology and development. But what we're finding across a number of these, and I think it came through in the talk about wind, is where we're drawing the line in terms of an extreme climate event or a climate event that has extreme impact. So when we talk about the case of wind and the problems in terms of wind for the operations of ports and harbors, those are not necessarily extreme climate events at play. That is wind that is very regularly being experienced at these harbors, but that is significant enough to prevent operations from taking place. So we would normally call something an extreme climate event if it exceeds the 90th or the 95th percentile, if it's an unusual event in terms of its frequency or in terms of its severity or both. And so if we're starting to talk about things that are becoming a real regular occurrence in our region, if we're talking about wildfires, if we're talking about wind events, if we're talking in terms of health about the cases of respiratory disease, such as influenza, we're often seeing that there is a very significant climate relation, which may speak to extreme impact, but may not be an extreme climate event. And I think it's important for us to start to differentiate those. And part of that is about how we use our indices. So if, for example, we're using the ETC-CDI and the ETSCI indices, there is some wiggle room for us to be able to make our own local threshold statements in terms of those, about how many days, what kind of threshold, both in terms of absolutes and percentiles. And I think that that's valuable. But I also think that when we're talking about a developing country setting, and when we're talking about the significant impacts that even regular climate and weather can have on us, that we need to start changing our framing of what an extreme climate event is. And we need to look at it both in terms of what the weather and climate is doing and where we exceed particular thresholds, but we also need to be looking at it from the perspective of what is happening in each of those sectors and at what point we're starting to feel the effect of these events. So we may find that the problem in terms of wind and harbors occurs 50% of the time, or occurs over a very, very small wind threshold that's being measured on site. We find that if we're looking at respiratory disease, we use international thresholds. There's a 5% threshold used in Europe. The CDC uses a threshold of that first case that's reported, that gives us every single week of the year in most South African provinces, and indeed where we've got significant case numbers in most South African towns. So should we be looking at extreme climate events from the side of climate and an unusual climate event? Or should we be looking at what is happening to our sectors and identifying where those sectors are feeling the heat and looking at what climate threshold is responsible for those. And I think that's one of the research directions that we need to be focusing a little more on, and that we need to be driving from the Southern African perspective, where we do have such vulnerable communities.
Thanks, Jenna. I think that, to use a phrase that I hate, in turn that I hate, segues very well into Alina's input, because you spoke about sectors and being sensitive to the sectoral requirements. And I'm going to guess that Alina's going to mention something about the DFFE approach to that. So Alina, let's hear your points of view. Also, Alina is Delani today. Good morning, Delani is Alina today.
And I realized from the last just a few minutes ago. All right, and I'm from TFFE. Just to give context to what am I doing. We are responsible for coordinating the climate change adaptation efforts in the country through our national climate change adaptation strategy. Am I audible enough?
I think the microphones have stopped working with the microphone. Okay, so carry on shouting. That's just for show.
I think it's now.
Oh, it's
Now it's on. So I'm saying I'm responsible for coordinating climate change adaptation efforts in the country through the National Climate Change Adaptation Strategy. I think one of the most dynamic things that happened through the KZN plans is that government throughout all sectors, interest was spiked because everybody wanted to put an opinion and statement forward regarding this. Okay. I was saying that the KZN plans were quite dynamic for government, because everybody in government across all sectors wanted to have an opinion or put a statement forward about what happened and why it happened. And some of the key questions that are coming to us from various management of government, whether it's at an executive level or at a political level, is that to what extent was it climate change? And what extent was it non-climatic factors that contributed to the intensity of the impact in KZN? And I think when you look at that, then you also realize some of the gaps that are happening in the country, because you could be talking extreme events of a set amount of magnitude with a set frequency. But the reality is that when you look at the social economic factors in the country, the impact won't be the same, even in one province, but in different areas because of such factors. And those are some of the issues as government we are claiming to say, yes, you can never, politicians normally don't understand that when it comes to science, you cannot be 100% saying that's to an extent. But when they start asking about non-climatic factors, then we don't have a lot of information that completes the story around it. So part of the work that I'm involved in is the creation of the National Framework for Climate Services. And the main objective of the NFCS was really to enhance climate services in the country. And when we say enhance, it was to say, how do we make climate products accessible to everybody? And when we say accessible, it's just to say, it's not just about delivering the product, but to ensure that different users of climate products can actually use it. The education level of my grandmother in Kwakwa is not the same as me. When you talk about the land, she only wants to know whether it's going to rain or not. And NFCS wanted to look at that. So when we adopted NFCS like South Africa, we were taking it from the WMO through the GSPN. And the main objective for them was to say, make climate information and data available for everyone, and ensure that climate services is a public good for everyone. But unfortunately, in the South African dynamic, it's not possible. Well, not in this current situation now, but it's an ultimate goal that we can try through a phased approach to reach. Because we have various dynamics, we know that we have some of our institutions that are not able to provide all the climate information and data that they have for us. And for many reasons, it's not just because they're being funny, but it's because there is issues around finances, on how their institutions are made up. Because unfortunately, with government, every year, the government contracts
what you got this year, it's not what you're gonna get next year, it becomes less. And not because climate services for government is not an important issue, but there is a lot of competing priorities in the country. But it comes back to the issue of working together to say that we have a lot of institutions with various mechanisms of finding that they are funded too. How about we, the MSCS, work together to ensure that we have a bigger impact in terms of the type of products that we produce, as well as to the what extent do they reach to our users? Because I'm a sole believer that when it comes to climate services, we must always, from the onset, be having the end user in mind to say, who is this product for and why? And then a lot of issues around who did it first and how can be reduced. So as government, we're releasing the NFC, and we're actually currently at the space whereby we've been working with Neville and Guy around understanding what is the best funding model that can fund climate services in the country. When we look at the main key government institutions that are driving climate services. So through that way, we are also looking at revising actually our current framework so that we can be a little bit more inclusive and exclusive. The first version we had of the NFCS was more government-led, but we saw that government cannot do it alone. And hence why I would like to also use this opportunity to really invite them maybe to participate in the NFCS.
Thanks. Charlotte's next, you just reminded me to say one thing, which, by the way, that report, it's due tonight, and I would like you to please go on time. But that aside, but I mean, I think you're probably too young to know when I say the Lanesburg floods, what I'm talking about. I think you're right. I'm afraid I'm not that more than I can't. But the Lanesburg floods changed weather forecast, and the drought. There was a drought in the 1950s, which I don't remember, which I'm told has resulted in legislation that today supports the WRC. So these events have happened in the past, these extreme events, and they've had big impacts on policy. So this is another one, which is fortuitous in the sense that it's happening now with the climate services. So that's interesting. Let's hear from Charlotte, and then we'll see if there's any input from the floor.
Thanks. I think my fellow panel have stolen some of the things I wanted to say, but I think I have to address the elephant in the room. And I know whenever I come to events like this, I wear my bulletproof vest because it gets quite heated when people want data, and I understand that, and so does SOURCE. We would love to advocate for open, free data. It is not that we are sitting on this data trying to think, oh, we're going to do all the research on it before we give it to you guys. We know that's not possible. So I just want to say that I think that is one of the big issues in the room. Data, access to data, quality control of data, helping to get all the data, all of those good things. And I think that if we can ask this community to advocate and to push forward a call for an environmental data set. So what I'm saying is we've got pockets of data sitting everywhere. SOURCE has got this data, ARC's got this data, RAF's got this data, the ZZ tomato farmers have got that data, the grape farmers have got this data. And if we could pull that together and somehow advocate for fully funding that data, that it is top quality, it's in a more spatial gridded format across the country, so we don't have these great gaps over the interior of the Eastern Cape. And that we can advocate as a community to governments that these types of data sets need to be fully funded. And when I speak about these issues from a SOURCE point of view, people say, oh, but you get a government grant. But as the leader says, our government grant shrinks every year. And just to give you some perspective, our government grant that we get is not even covering our salaries. So then government comes back to us and says, well, you go and order, you get some money from somewhere. And the only thing we've got to sell is our data. So I can really sympathize, but and then the other comment that we made at the frontier is students get data for free if you don't want a whole data set, you know, the whole country's data. And a lot of the presentations that students have given in this conference is based on source data. So it's not that we don't give data. However, if you're not a student, you're going to say, but Charlotte, that doesn't help me. Can I just say that if you bring in a source scientist on your project, you get access to the data through them. So you might not get the raw data, but they are able to process the data and help you. So that is a way around the data policy, is if you bring in source at the beginning of the project. But a lot of people do a project, they do a project proposal, and then at the last thing, oh, we need data, oh, it's unfairly charging. So please, I just want to say, if you could call us first when you scope in your project, or just involve us a little bit more, we can perhaps work together around the data policy, because at Source we really want to support research. We don't want our data just to be in the archives gathering dust. So I think from my point of view, I would love to be part of anything that looks at these extreme events, and our really Source wants to be part of the solution rather than the major stumbling block in the chain. So thank you.
Thanks. I mean, I can just say that in the report that we have produced, where Source and GFFE have addressed this very question. How do we fund climate services in such a way that we make it work? And fundamental to that is making data available, but not just from Source. And data is a commodity like it is everywhere else in the world. I just want to see if there's any comments on what was said by the panel, or questions for the panel from the floor. I know it's late. Oh, I see quite a few. Okay, let's take 3. Can we start in the front and work backwards? Okay, starting with you here, and then you being Stephanie. Christine. Sorry, wives.
Yeah, I've got a quite different view, I think, of maybe what the panelists have enlightened us upon now. I think quite a pragmatic kind of view to take whatever kind of climate challenge we face here in Southern Africa. I mean, mentioning about working together, not in silos, it's been going on for decades. It's as long as our observational history is. Climate data observational history is. The problems of funding, I mean, it's a dream to think everyone must work on one big project and everyone is going to get the money they need for the organization to survive with the case like this. It's just not going to happen. So, I mean, it's the ideal situation. I don't see it happening in the near future. So I think these kind of things saying it's a quite idealistic kind of view. What we need is something like that. So maybe I'm talking to the youngsters, because for us that's all there is, maybe too late. Or that we can always try and never stop trying. But, and I mean, and again, also the issue of data not being freely available. And Charlotte has got a bullet vest. I'm just very plain angry. I think we must just work with what we have to the best of our ability, and to target whatever is your passion in trying to solve this. Whatever challenge there is. And I mean, the challenges are different for the various sectors. So, while trying to solve all these problems, the time bomb is ticking, and we are losing time to work with what we have to the best of our ability. So I think that is my contribution.
Thank you. Well, yeah, it's very helpful. And I think that the data issue, I think, is solvable. It is solvable. There are ways around, as you suggested, and I also think it's solvable from a financial perspective, if there is the political will to do it. That's what I think. Who had a hand up? Yeah.
Hi, my name is just a comment. I come from a civil engineering background, so all of this learning about climates was quite overwhelming.
But I have something to say to the panel on that, how do we adapt? I've read everything about what people are studying about rainfall and all of that, but how do we create resilient cities? That should be what we should be looking forward to. How do we work together with people who are studying climate, with civil engineers, with so forth and so how we work with communities as well? Because those are the people who are most vulnerable to everything that they want to study. So if we're not going to work together and learn how to adapt, each and every year we're just going to be doing one and the same thing if we never adapt to it.
I want to just add your question, which I want to ask the panel to respond to, after the next comment there. And that is not how, but also not only how, but also what to adapt to. Okay, there was another hand up here. Yes. But, let's see how we go. I don't want to spend too much time. Go ahead. Give it a possible, possible.
Thanks. I think I also have another perspective from the panelists. I don't want to repeat what the first person said there. We are trying to, but we almost raising it always challenges. Issue of interdisciplinarity, issue of working in collaboration. But my point is, are we producing good science? Where we can be in complementarity with science, climatological science on extreme event, or science on the extreme impact of extreme impact of weather event. All of them should go, like together. But are we producing good science either in climatology or on the other side? That's I come again to the issue of I'm thinking like I would propose, for example, expert colloque nationwide. We can pass through different universities, organize different colloque, workshops, workshops where they can help us to understand the issue that one of the presenters raised here on modeling, the choice of the model, which kind of modeling process can help South Africa and not being just importing the same importing models. So I think to be a bit short there, that's the point.
Thank you. Let's just quickly take that. You've got like 30 seconds, please. And then we're giving the panel 2 minutes each because we have to finish 10. I'm told.
I'm a little bit of an outsider. Last time I did climatology earlier. So, but I'm a bit concerned about the weighting of our discussion. So I just want to also applaud the presenters today because they managed to, put the weighting correct. My main concern is the issue of saying climate events, because when you say climate events, I would expect that you would have data for over 40 years. So I think we need to now differentiate between extreme climate events and extreme weather events. So with extreme weather events now, if extreme weather events occur consecutively to the extent that they become the average, they will eventually become an extreme climate. So my main concern and comment to the panel is that the question is that what is actually causing the extreme weather events that we're observing, like the heat waves or your flood, your extreme rainfall and extreme temperatures, extreme heat. So can we attribute that to climate change, and can we actually have more research that is actually focused on attribution of what is causing extreme weather events? Because as an end user myself, somebody who's not in climate, I would want to know what is actually causing this heat, yeah, so thank you very much.
I'm going to give over to the panel to respond to any of the points made and questions made in the last round. This microphone is really not long. That was one. So take this one. And then we'll have one quick round and then we're going to have to terminate. Thanks.
Thank you. I'd like to tackle the one point, how do we adapt? So for me, I think we need to improve the signal forecasting. We need to improve our projection. This is key. Right now, we're using models that are made for the from European countries. Transfer is this big idea now that's very, very important, that's coming up with the high resolution global model, which talks to Southern Africa. So if we can support this, I think it will go a long way in terms of improving signal focus. If you remember presentation from manager, where she compared observation and GPA models, where she said that all of the models were quite far from observation. So if our own model, I think that can improve in terms of and also we need to improve our early warning system. Right now we have our system, but it might not be as effective as we want. So if we try to tackle that area in terms of early warning system, I think that can help. Thank you.
Thanks, Eugene.
I'll jump in on the question about adaptation. And I think that it's important to recognize in a space like this, and particularly where there is a special session, that often the research that's presented is very focused to a particular segment. But there is a very vast amount of research and scope of research that's being conducted on adaptation. A lot of it is sectoral adaptation, but there is also adaptation to specific types of events, as well as to a broader warming climate around us. That work on adaptation is often being driven by understanding communities and understanding at what point they are willing to change the ways that they live, the ways that they engage with their spaces around them. But as Francois really forcefully communicated to us today, you can have the best adaptation strategies, you can have the best evacuation plans, but where people are very tied to their homes, that they have spent their lifetime trying to build and trying to obtain, it's very difficult to get people to leave their homes, even in the face of a disaster. And so I think it's important that in addition to looking at civil engineering, and I've done a lot of work with civil engineers, in addition to the engineered responses, we need human responses, and we need to understand the psychology of people when they are faced with an extreme weather event the next few hours or the next day, and whether or not they'll leave the places they live in, and whether or not people are willing to put money in now for a climate event that is projected 50 years into the future.
I think Jen said everything I wanted to say around adaptation. But for me, it's also to say that for adaptation to really work at the ground level, is to understand that as scientists and as policymakers, we do not have all the solutions. But people who are staying in those areas are the ones who know the areas even better than ourselves. So it is also to say, how do we then ensure that whatever strategies or interventions that we place, that we always have that bottom-up approach, because it doesn't make sense to say that you develop, for instance, you will talk about community-based resilience projects, which will ensure that communities become more resilient or reduce their vulnerability to climate change. But it would not make sense for me to just not try to even understand your perceptions around the different geohazards that you may be facing or we are trying to mitigate. So for me, what is key is always key co-creation with all the key stakeholders when you are talking adaptation, because adaptation is not just policy and time, because it actually involves real people with real situations that are very dynamic in nature. And then another thing just attached to early warning system, more than just having early warning system, we also need to understand or improve our planning from the whole value chain when we talk about early warning and disaster risk reduction and management. Because you can issue a warning, but if we do not have an action for rapid response, we will die with the knowledge knowing that there is flood. Yeah. So we need to start also thinking to say, once you issue the warning, what needs to happen, and how will that response be architectured? Or so I think we just know most of the time when we talk about extreme weather events or climate services, for some reason we are always so concentrated to our key area of expertise, and we do not want to broaden out of that. And I think that's one of the challenges that we are facing, that even makes some of the responses that we have developed not to be most effective.
Thank you. I think from my point of view, I'm going to jump on Alida's and carry on that. It's very interesting in this conference. When I started out in my career, the main focus of the conversation was around education and educating the youth. And I haven't heard anything about education, except in the morning session where they were talking about that lovely idea where we had to, if we were at university now, maybe take credits in other disciplines or have that bus ride. Gee, I wish we had that when I was studying. It would have been very interesting. Maybe we would have been on bicycles, not buses, but anyway. So interesting, there was somebody in Japan who was saying in the tsunami, they were quite surprised at the number of fatalities in children. There wasn't many. And they couldn't understand this because it should have done a bell curve and it didn't. And what they realized is the kids practiced. They practiced in their schools what to do when that tsunami warning was done or however heard. So they all moved to higher ground. And so there weren't as many people killed in the school going ages. And I think that's the power of education. And I think we as scientists do some of it and we do some outreach stuff. But there's so many opportunities for us as scientists to engage with learners and the youth in a way that makes our science accessible and also practical in terms of what to do in these types of events. So I would like to see a bigger support for science festivals and things like that, where we think, we'll just get a few brownie points, we'll do an extra activity on the side, but we don't realize the impact that we have when we communicate our science to the younger people of this country. So I think it's a gap somewhere, and I'm not sure where it fits in. And I know that I'm adding it to another plate of things that we as scientists take on, and we keep looking at our plate and thinking, oh, is that another thing I'm supposed to do? So I think we need to find ways of engaging educators with our science. So maybe we don't do the education bit, but we empower educators to bring our message to the youth.
Thank you. There's a term there called climate awareness, it's climate intelligence, something that Australians are very big on, especially with business, in fact, not so much children. Look, there are a million threads to draw upon to finish this with. I'm trying to think of something profound to say, but I've got too many profound things to say. But I'm interested in what Christine had to say about just do it, right? Stop complaining about what you can't do, just do it. And I mean, I commend that point of view. I would agree with it, but I also think there is a need for a more coordinated strategy in specifically climate science as part of a bigger picture. I made this point earlier today. And I think that can define many priorities. It should be resourced, such a strategy, properly resourced, and there should be data. That's what we need to get right. And that's a sort of a generic comment, which I think hopefully will encompass everything. I mean, it's been a great day. We've heard a great amount of information from work, as we noted, a lot of stuff on Durban and on flooding, a little on some temperature extremes, nothing on drought. But nevertheless, still a broad range of very stimulating and thoughtful stuff. Great speakers, and I'm very grateful to the panel for helping us think some of this through. And as become tradition at this conference, I noted, we'd like to thank the chair. Okay. Okay, so, and listen, this team has been awesome. They really have been very good. Thank you very much. I think we'll go to the bus if you're going to the planetarium. So we're going to now about
a school announcement. If you look at the back of your cards or ties, there are two dates. So there's two groups for dinner arrangements. First one is for Neighbor Hill and the second for Observatory. So if your case is today, you go to the group at the Observatory. Just check it there. There's two buses. So spaces are limited, to just make sure you can run out fast. Because you won't have them on Thursday. So, yeah.
thank you all. Yes. As long as you go to the right of way.
To drive. Do you know where the video is?
Follow the bus.
Just all
right. Thank you all very much, and thanks for all those who helped.
Okay.
Okay.